Hello and welcome everyone to another episode of the WeAreDevelopers Live Days. My name is Bene. I'm here live at the headquarters of WeAreDevelopers in Vienna, and I'm happy that you all join us today. So today is all about FinTech, but first, a big shout out to our partner of the day, SingleStore, without whom events like these wouldn't be possible. So make sure to scroll down on the live page, click on the logo and check out all their offerings. And now, before we start with the first speaker of the day, quick reminder, you can interact in the chat to your right, submit some questions if you got any, but during these interactions, please be nice to each other and respect each other as we have a code of conduct. Here's a short video about it. And now let's kick off FinTech Day with the first speaker. He is technical evangelist at SingleStore, and he held multiple roles such as developer, consultant, product strategist, evangelist, technical writer, and technical trainer. And besides all of this, he still finds time to help building global developer communities. Welcome, Akmal.
Thank you very much, Bene, and thank you very much to all of you for attending. So wherever you are, good morning, good afternoon, good evening. So for me, it's just gone 9 o'clock in the morning here, so a bit early for me, but there we go. That's life.
Then thank you so much for getting up early for us today, Akmal. Really appreciate it.
I'm a night owl. So.
I totally understand. You can go to bed afterwards. But maybe let's talk about the next hour. Would you mind sharing a bit with me and the audience what we are going to learn from you today?
Yes, so what I'll do is I'll show a few slides, not that many, just talk a little bit about the background and history of SingleStore and where the product came from and essentially some of its capabilities. People sometimes ask that question, what is SingleStore? And therefore, I'll talk through that and describe some of the features of the product. And then we'll focus on FinTech, obviously, because that is the focus of today's sessions. And then I've got some demos to show you. So I'll demonstrate a little bit of SQL code, how you can use it for doing some type of sort of FinTech operations. And then we'll use a little bit of OpenAI and LangChain in terms of AI type stuff, just to show you some of the capabilities, in natural language. That's the key thing. So if you are not so familiar with SQL, for example, and you might say, well, I'd really like to ask some questions. Maybe I want to do some tracking of some stocks, see what their performance is. Can I ask these questions in English to the database system? And indeed you can. And then finally, I'll kind of wrap up with a couple of demos, some code that actually shows you how you can do voice control. So I will speak to my computer, ask some questions, and then it will respond back. And I've got three kind of versions of the program. So there's a basic version that just gives me text back. Then subsequently we build upon those, and eventually the last version, fingers crossed, will actually speak the results back to me as well. So that's really the focus. So obviously a little bit of code, and then we've got the links to these resources as well, so people will be able to try this out for themselves later.
Yes, we'll post them in the chat. And yeah, very much looking forward to the live demos, as also the audience always loves some code demos. And I would say without further ado, Akmal, the stage is all yours.
Great, thank you very much. So let me just switch to this tab here. And again, Vinay, please let me know if you can't see what I'm trying to show. And I'm hopefully, there we go. So that should be the first slide of the deck. So OpenAI for FinTech, building a stock market advisor chatbot. So as I said, my name is Akmal Chaudhri. I work for SingleStore, and I've been with the company roughly 2.5 years now. And before we go further, an important disclaimer. We're going to be using some stock data today, okay? And it's very important to be aware that this stock data is entirely fictitious, okay? It's made up, okay? So please do not use this data for making any kind of financial decisions, okay? If you do so, it's your risk, okay? This is purely for demo purposes, and it's just made up numbers, all right? And you'll see how to access this data yourself, okay? So that's very, very important. So as I said before, I work for SingleStore, and my background is actually database systems. So Vinay very kindly gave me a glowing introduction there. So having been there, done that, got the T-shirt over many, many years in terms of, the IT experience that I have, it's great because it gives you a wonderful perspective on life and many of the kind of problems that are faced in building, systems and applications in the real world. And so that's something that I value greatly, because that life experience, I think, helps you understand people much better, and specifically developers as well. And so one of the challenges, I think, for the developer community today is really trying to get to grips with all of the diverse systems, packages, frameworks that are available, and then, figure out which one of these should you be focusing on and learning more about. And then AI is a kind of a natural one, simply because of the immense interest and the development within the last kind of, I would say, almost 1 year now, since OpenAI released the ChatGPT. I mean, everything has just taken off and ballooned. And so our focus today is trying to look a little bit about how it might be useful in the fintech space and how we might be able to build a chatbot. So as I said before, I don't have very many slides, so a little bit of an introduction. We'll drill down specifically on that sort of fintech, and then I'll just dive straight into the demos. And so there is an associated blog post for the demos. Okay, so please don't worry. There's no need to note things down. Okay, that has full instructions in there. There is a GitHub repo as well associated with this. One caveat that I would add, and I was talking to Benny a little bit earlier today, is that in this space, in the AI space, when you are using some of these libraries and frameworks, unfortunately, things break sometimes, things change. It's just the nature of, the world today. So I had some issues this morning in terms of one of the demos I wanted to show you. It's something that I will look into and try and fix. So I excluded that for the moment. But the rest of the stuff, I will highlight to you where there is something that needs to be changed. And I will go back and amend the blog post accordingly, okay, so that the instructions are concise and you'll be able to follow those along. Okay, there we go. And then, so what is the focus today then? So here are the key things that we hope to cover. Okay, let me try and get my box here. So essentially, how to manage stock tick and stock sentiment data using SingleStore DB. And then we'll sort of drill down into some of the AI type of stuff using LangChain, okay, and specifically this thing called the SQL agent, which is great. So with very little coding, a few lines of code, essentially you can communicate with SingleStore DB using English. Type your sentences in English. And as I said before, actually have some code later on where you can speak to the database in English, and it will return a result back for you. Now, that's not something particularly new. I think people have been trying to do natural language processing with database systems for quite a long time. But the thing is that today, literally in a couple of lines of code, anyone can do it. And that's the wonderful thing. Okay, so that's very, very straightforward. And in order to achieve the kind of speech to text, we will be using OpenAI's open source Whisper. Okay, so this is actually available on GitHub, and you can download it and you can use it free of charge. And what I would say is that you could use this service from OpenAI as well, okay? Or you can use the open source version, which is on GitHub. I opted to use the open source version simply because it's installed locally. And, I have some resource constraints in terms of my laptop and the environment that I'm running in. And it's kind of saves a bit of time simply because I don't have to send things across the wire, across the internet to OpenAI, and then for them to do their the conversion of the speech to text and send the results back. Because it's local, it does it locally, and it's much faster. Okay, and they get pretty good results out of that. And then finally, just a little bit of information there on how to build a sort of basic chatbot for questions and answers. And then we'll use a couple of examples that might be relevant to the fintech space that, you can query your stock data and so on. Okay, so we'll look at that as well. All right. So a little bit about SingleStore DB then. So what we've seen over the last 10 years or so is the development of these distributed SQL databases. So go back in time, once upon a time, 20, 30 years ago, you saw these kind of monolithic products on the market. And essentially, if you wanted more processing power, you buy a bigger box. Okay, that could be quite costly. With the advent of distributed systems, I guess if you could point to things like Hadoop and Spark as the sort of precursors, the things that paved the way for a lot of the developments that we have today. This idea of kind of scale out, being able to use off-the-shelf components, distributed data, bring the processing to the data, keep the data where it is, and then don't move that around, but bring the processing power to the data and then be able to run that where the data are. That's something I think very, very useful. And so SingleStore is an example of a distributed SQL database. And it also offers a number of other interesting capabilities. So historically, you may have known it previously as MemSQL a few years back, where it was really focused on OLTP and very much kind of in memory. And that's where its awesome performance came from. And so over time, over the last couple of years, there's been this additional kind of development as well in terms of columnar storage, analytics, sum, min, max, average, count, these kind of operations that we want to run on data at scale. So it can do that as well now. So broadly speaking, if we look at it at sort of the 30,000-foot level, here's a kind of high-level overview of the product and some of its capabilities. So this concept of universal storage, okay, this ability to store and manage both OLTP and OLAP using a single table type. Okay, there's a patent for that. And then, of course, it can integrate very well with a lot of these other technologies. So we'll look at a little bit of Kafka today. So I've got a feed that's coming in and bringing in some tick data into a database table. I'll show you how I set that up. More broadly, I've used Spark previously as well. Okay, that's great. It offers a number of interesting capabilities, such as push down as well. So there is a Spark connector that SingleStore provides. And then, of course, there are external sources that you might want to use as well. I've mentioned Hadoop, HDFS as one of them, but equally there are other data sources that you could use, say an S3 bucket or something like that. It's available on the 3 major cloud platforms in the Western world. Okay, so AWS, Google Cloud, Microsoft Azure. Today, I'm running on AWS. Okay, and I'll show you that a little bit later on. It can be run on-prem as well. There's a Docker container too. And what I would say is that I'll show you how to register for free access and get credits for this momentarily. But the thing is that with this account on the SingleStore portal, essentially you can get a license as well, which will allow you to run a 4-node version in your own environment, and that is a full version. It is not crippled in any way. It's not limited in terms of its features and capabilities if you want to do the on-prem version, and we do have customers actually running that as well. Okay, so SingleStore is multi-model as well. So obviously very strongly based around relational technology, and it also does geospatial. Time series is something that we're going to look at today. Full text search is available as well. Okay, so the Lucene engine is built in. You could even run and manage key value. Let me just get my arrow here. Okay, so JSON support has been in the product for quite some time as well. And better JSON support has come about this year because of this product called SingleStore Kai, which it gives you compatibility with MongoDB. And more broadly, so I mentioned the relational, so it's MySQL wire compatible. So if you're familiar with MySQL tools, the sort of SQL dialect, if you like, then that will be something that you can move across very easily to in terms of using SingleStore DB, but it is also MongoDB wire compatible. And the last thing here is vectors. Okay, so just again get my arrow here. So the vector support in the product has been there since 2017. Now, obviously, it's a very interesting and a topic that's garnering a lot of focus today, simply because of these embeddings and the ability to do these, retrieval augmented sort of generation, and sort of querying and these kind of things, and being able to do semantic searching and so on. But remember this, that the product has actually had that support since 2017, originally requested by a financial customer. And so it's pretty mature, it's robust, it's battle tested, but we're not sitting on our laurels, as they say. Improvements are coming along in the next major release, which will be due, I think, next month. So more interesting stuff coming along as far as vectors are concerned. Finally, just to wrap up then, so real-time decisions, AI apps, dynamic experiences, and of course, you can use your favorite technologies for creating your dashboards. So Tableau, for example, if you are a Tableau user, in the past webinars, I've shown Metabase, for example, which is something that I particularly like, just because it's free to download, and you can configure that and set that up very easily, and then create some nice visualizations as well. Okay. So here are some of the ways that you could do machine learning with SingleStore DB. So we mentioned a couple of these already. So Spark I've mentioned, and this is not an exhaustive list. This is just some of the examples that are possible. So earlier this year, if you attended one of the previous sessions that I did with WeAreDevelopers, we talked very much about the code engine using WebAssembly. Okay, so I showed how you could do sort of machine learning using WebAssembly capabilities in the product. But the focus today is very much around sort of OpenAI and LangChain. Okay, so specifically then for FinTech, well, it's disrupting the status quo. Okay, so huge potential, huge market, hundreds of billions of dollars worth, and lots of global adoption. It's 25% there. And then you can see that at least most people seem to be aware of some aspects of FinTech and sort of FinTech services. So here, according to this survey, 96%. Now, notice here in the background, I don't know if you can see it. I'll try and just highlight this for you. Just within this kind of area here, you can see these kind of graphs and charts. We'll look at those momentarily as well and show you how you can actually generate these yourself directly from Jupyter, although this is fairly easy to do anyway. I mean, there are packages to be able to do this for you. I use Plotly a lot, so that's one way you could do this. And then in terms of use cases and demand, well, lots of potential and possibilities here. So here you can see, and again, let me get my box here. So advanced risk analytics, for example, real-time investment performance calculations, streaming market data, which we're going to do a little bit of today, embedded finance apps. And then more broadly, in terms of some of the applications, things like peer-to-peer lending, which I think seems to be very popular today, and alternative payments and financing. And so broadly speaking, I mean, you can see that there's a wide range of different use cases and quite challenging in terms of the requirements then. How do you meet all of these requirements? Well, some of the things that you may need to do, things like harnessing, for example, the real-time data, being able to get your insights quickly. Split-second decisions sometimes often can make a huge difference. And SingleStore definitely simplifies your architecture because of all of those multimodal capabilities that we talked about. And of course, it does very well in terms of scale and performance, particularly for concurrency as well. And then just down at the bottom there, you can see some examples of the customers in the financial space that are using the product. Okay, so like I said, I don't have too many slides, so just enough to kind of cover it, and the demos really are the main focus. So specifically for the demos then, what I'm going to be using is a couple of tools and technologies. So we'll obviously use OpenAI, and I've mentioned the open source Whisper. Okay, so that's very useful, available in GitHub. For some sentiment analysis that I performed, I already kind of did that for you. So that is not something you have to worry about. But what I used was something called Finbert and Hugging Face for that. Okay, so there's some data that's already created for you. Now, there was a kind of a limitation in terms of how much I could do. It's simply some resource constraints that I have. I may get around to completing this for a larger data set. Okay, and again, if I do so, I will put that on the GitHub repo for you. But at least you have something that you can start with. And actually, the sentiment analysis, it relates very well to the WebAssembly presentation that I did earlier this year, where we actually did that for movies, and trying to be able to read phrases, determine the sentiment. Is it strongly positive, strongly negative? Is it neutral, and so on? So that the tools and technologies there could be something that could be applied to this problem as well. So I'll show you the data that I've done for you, quite small subset, but equally, you could extend this much further. And then finally, in order to get this kind of conversation going with the database system, we're going to use this framework called LangChain, which is extremely popular today. And in particular, this sort of SQL agent, which is very, very simple to use. Just a couple of lines of code, and you can get that going. Okay, so there's the summary. But now let me switch over and go to a different window here. Okay, different tab. So a couple of things just to mention there. Hopefully you can see this. And so for the cloud trial, let me see if I can pick this up. Okay, so it's at singlestore.com/cloud-trial. It's a sign up page. So just asks you for some details. And if you don't wish to use Google or Microsoft, literally you just need your first name, last name, and an email address, and that will give you the option to create a free account. Less than 1 minute of your time to do this. So currently, SingleStore provides $600 in credits. Okay, they just mentioned over on the left-hand side here. Now you might think, well, $600 is not very much. You might, I'm going to burn through this very quickly. Well, let me just share something with you. So as I mentioned a little bit earlier, I've been with the company almost 2.5 years. Just before I joined the company, I created a cloud account for myself. In those days, I think it was $500 that was being given away, and I still have credits today. So, it's great if you manage the credits carefully. Shut down resources when you don't need them. Don't leave things running, okay? And then that saves money and saves you credit. So I'm still burning through my credits even today, a couple of years after I'd created the account. And so once you've signed up, literally your environment will look something like this. Let me just go to the, here we go, home page. Okay, so it will look a little bit like this, okay? So you'll see that on the left-hand side, there's a whole range of controls in the left nav here, and we'll be using a couple of these today. I've made the browser display a little bit bigger, okay, so you can see that more easily. And then you've got various links in the middle here in terms of guides and so on. And so the quickest way to get started is that if you see here on the left-hand side, again, hopefully you'll be able to see my arrows and boxes. Either select group on the left there or workspace group here on the right. I have something already created, but if you were to do this, essentially it will just ask you, give it a name. And here it's picked up a kind of a default. Okay, you can keep that if you want to change it. And then who is the cloud provider that you are planning to use? As I said before, I'm using AWS. And again, just pick your region. Okay, so I've got the one that's closest to me, which is Europe West 2 here, London. And you can just do next from the bottom here. And then again, just give your workspace a name. Again, you can choose to give it the default. And then here you can choose the size. So this is the smallest size available, which is S00. Okay, so it's 2 virtual CPUs, 16 gigabytes of RAM, and it burns through 0.25 credits per hour. Okay, you can see tiny amount of usage there. You can change this, of course. And if you really want to, I think, let me just scroll down to the bottom. You can get yourself an S384, which is over 3,000 virtual CPUs, 24 terabytes of RAM, and that uses a hefty 384 credits per hour. So that would, burn through credits very, very fast indeed. But this is fine. I mean, the S00 is more than enough for small-scale testing. One thing I should add is that at the SingleStore Now conference that we had in San Francisco just last month, excuse me, there was an announcement that for developers, there is a kind of free tier that will be introduced, and I think expect to see that next month. Okay, so you have less to worry about in terms of credits then, and then you can just say create workspace here. Okay, at the bottom. Now I've already done this. Okay, so I won't do that now. Okay, just go back here. So the key thing is that once the workspace is created, you'll be able to see it here. And SingleStore uses this notion of separating storage and compute. And so you can create multiple databases. Here on the right-hand side, you can see I've actually got a database that it's connected to. And this one happens to be called Time Series DB. I'll just show you the structure of that in a moment. And so I've got read-write privileges on that here. You could change that to read-only if you wish. And you can attach multiple databases to this workspace. And so as part of this as well, again, you can get the details in terms of the connectivity. Okay, so if you want to plug in external tools, so we can have a look at this, say connect directly. So here it gives you the option to, if it's a client, say a MySQL client, you literally get the full connection string here minus the password. You just need to copy that. And then again, depending on whether it's an IDE, okay, and other things as well. And if you have the Mongo SingleStore Kai enabled as part of the process of creating the workspace, you will get the MongoDB connection string as well here, okay, which you can use. Okay, great. So once you provision it, once you've selected this, the provisioning process takes a couple of minutes. And so, as I said before, I have that running already. As you can see, I've got a workspace and an S00 selected. And let me just show you. So within the left-hand side, there is a SQL editor. Okay, and let me show you what I've done here in terms of the database I've created. It's called Time Series DB. Okay, at the top here. And I've got a table for managing tick data here. Okay, so it's got a couple of fields, one for the symbol. I've got a timestamp as well there. And then I've got the kind of open, high, low, and the closing price. The volume as well. And then I've got a key created as well on the timestamp. Just below, I've got another table in terms of where I'm storing some stock sentiment data. Okay, so this was using the Hugging Face and Finbot to create this. Okay, so as I said before, there's slight limitations in terms of the size, but that's purely a resource issue for me. But I will try to generate a larger data set for that. Okay. And we'll take a look at that as well momentarily. And then what I have here at the bottom is, let me just move this in the center here. So this is a pipeline that I have. And what this pipeline is doing, it's connected to a Kafka feed here. So this is a public Kafka from SingleStore. And we have this stock ticker. It's being read into this tick table. And then I've just described a little bit about the structure of the data that's arriving here at the bottom. Okay, just to be a bit more kind of specific. I've also throttled the sort of feed a little bit in terms of the batch interval here, 2,500 milliseconds. And essentially, once this pipeline is created, all I need to do then is to start it, which I've done just below here. And again, all the instructions for this will be available in the blog post. And then I can show the pipeline here. Okay, so let me just run this. And just below here, okay, I think it's just off the bottom here. Take a look. So here it shows you that pipeline. I think a box is better for this rather than an arrow. There we go. It's currently running. So data's coming in, and that's been running for a little while now. So if I look at the time, it's about 9:30 at the moment. So this has been running for about 2 hours or so. So there's quite a bit of data that's already loaded in there. So we can just take a look at this, and I can do select count star from. Let's just run that. Look at that. So at the moment, that value is it's 100 and let's see, 1, 2, 3, 1, 2, 3. It's about 16 million, 16.3 million rows currently. And again, if I were to run this again, it will update that number. Okay, so the feed is there, the data are kind of arriving in, and this is kind of simulating, you know, a stock tick feed. So remember, the data here are all fictitious, okay? So please bear that in mind. Again, can't stress that enough. So that's essentially it. So we've got a database created, a couple of tables there. We've got a pipeline, some data being streamed into one of these tables. And if we now just switch across to here, so as part of this environment as well, you can create these Jupyter-like notebooks. Okay, so notebooks, this is a feature that just went GA very recently. And so if we run through this, okay, let's take a quick look at this. So there's a couple of standard things that we can do. So we can find, for example, the average aggregate. And the key thing to remember here is that at the top here, I'm connected to the workspace and the particular database here. Okay, so if you have multiple workspaces and multiple databases, you will have more options available here. So this is just doing the average aggregate. There we go. And because this is in kind of, and I'm limiting it to 5, and then just, it's in alphabetical order by symbol. There you can see the values returned. Okay, here. And we can do a bit of time bucketing. Okay, so you can the first, last, the actual time bucket. So that was on that graphic that I showed you in the slide. Okay, so here's the kind of the text equivalent. Now, the thing is, this is for the symbol AAPL, Apple. And we can also create these candlestick charts here. Okay, so again, using the high-low sort of, min, max, first, last. So this gives us this output here. And then we can represent this graphically as well using Plotly. Okay, so if I just run this, and it's asking me how many days, let me put in 5. And what's the symbol? AAPL. We'll do the same one. And it will just generate that for me. There we go. These kind of candlestick charts. And again, because I have no control in terms of the data, I mean, I'm just taking the feed, it's just getting the data in. So you may see some strange results here, but that's just the nature of how the data are being generated. We can do other things as well, such as smoothing. Okay, just using standard SQL there. And then again, this thing called as of, finding the value as of a particular point in time, okay, which is actually today's date here, 8th of November, 2023. So it's giving me the last row here. So all very standard, but requires a little bit of knowledge of SQL, as you can see. And maybe, perhaps the SQL is not very complicated. I mean, the examples are fairly straightforward and simple, but there may be more complex things that you want to try and do. And so the sentiment data here, as I said, I've loaded in about 300 rows. This is the other table here. And so essentially what we've got here is the headline. That's and then we've got using the Finbert and Hugging Face, I was able to generate the positive, the negative, the neutral, and it's all for one particular symbol, the symbol just A. Right. So as I said before, I ran into some limitations for this, but what I'd like to do is to generate this for the entire data set that's available there rather than just 300 rows. But it's enough for illustrative purposes. Okay, and we'll use this symbol momentarily. So that's the other table. And then here, what we'll do is we'll use a little bit of LangChain. So let me just run this. Okay, just set this up. So we're just going to install LangChain. And a word of warning. So OpenAI have released the latest version of their software and libraries within the last couple of days. And I found that there was a slight problem with my code because it broke some stuff. So here is one of those gotchas that I promised that I would mention to you, just using this particular version of OpenAI, which is 0.28.1. And that ensures that the following code actually works correctly. Okay. And I will update my blog post and the GitHub repo accordingly as well. So here it's just prompting me for my OpenAI key. So bear with me. Let me just copy that and paste that here. There we go. That's done. And now what we'll do is we'll use this LangChain SQL agent. Okay, so just again install these. And then so here, literally, as I said before, a couple of lines of code to be able to set up the environment so that we can ask questions in English of the stock data that we have. And one thing that I've done here is set this thing here, verbose mode, to true. What this does, it will show you what its kind of thinking is. What are the sorts of steps that it took in order to arrive at the answer. So let's just set this up. Okay. And that's done. And then finally, here we can ask a question. So the question I've got here, which is kind of hard-coded, is from the tick table, which stock symbol saw the least volatility in share trading in the data set? So if I just run this, okay, you can see here, because I set verbose mode to true, essentially the agent is showing you what is the process that it arrived at in terms of getting the answer. So it shows you that, yep, it's interrogating the tick table, it's looking at the rows, and then again, you can see the observations that it's made, and then the final answer that it gives at the bottom, it says the stock symbol with the least volatility, there we are, in share trading in the data set is FTR. Okay. And so at this point, rather than having this hard coded, what I could potentially do then is just set this up as I've done just below here and actually have it prompt me to put in a question. So this makes it a little bit more usable in terms of kind of like a chatbot environment. So it just says here, please enter your question. And now it's waiting for me to type something in. So I've got a couple of canned questions here, which I'll just sort of copy and paste here. So let me try something using that sentiment data that we have, okay? So I'll paste that in here, all right? And I'll tell you what the question is. So the question I'm asking is, using the symbol A, what is the most positive sentiment in the stock sentiment table and the current best price for this symbol from the tick table? So you can see here that I'm being quite precise in telling it which tables I want it to access and the kind of relationship that I'm looking between them. So let's put that in. So again, because we have the verbose mode enabled to true, you can see now that it's interrogating the stock sentiment table, okay? And it's looking at the tick table, and it's showing you its kind of thinking process of how did it arrive at the answer. And then the answer it gives at the bottom there is, it says that the most positive sentiment in the stock sentiment table for symbol A is 0.9576. Okay, so remember, higher is better. I mean, 1 would be perfect. Okay, and then it says the current best price for this symbol from the tick table is 45.51. And you can see that's pretty good going. So a couple of lines of code will give you this ability, and it would be a lot better if, rather than just having that single stock symbol A, if we could do this for the entire range, the full data set of all of the symbols that we might be currently reading in from the feed that we have. So as I said before, it's unfortunately a small limitation in terms of my environment. I could only get up to a certain point, but that's something, again, I will look at and see if there's a better way to do this. Okay, so very straightforward, super easy to do. And again, you can see the ease with which this allows anyone with sort of non-SQL skills to be able to now interrogate the database. But you do have to be quite precise. You need to be unambiguous. Give it enough information and context so that it kind of understands what you are trying to ask it, and then we'll give you the result. All right, now let me just stop sharing this for one moment, and let me switch across to the virtual machine. Okay, so I'll just stop this for one moment, and then I'll need to present, but do so from a slightly different screen. So bear with me as I choose the window. So hopefully you should be able to see my virtual machine now. And it's got the time there, 9:42. So we have a couple of minutes, and that's going to be perfect for this. Okay, so there we go. So here, let me just show you this directory. Okay, so again, this code is available. Okay, so I've got three different programs written in Python using the OpenAI Whisper technology. And let me just run the first one here. And then what I do is I'll minimize the, once it's launched. Okay, there we go. Let me just minimize this. Okay, it's less of a distraction for us. There we are. And here's the kind of audio recorder. And so what this will do is let me ask a question. Okay, and let me just again pull up my list of questions that might be useful to do. So let's have a look. Okay, here's a simple one. What is the structure of the tick table? So let me just ask this. Start recording. I'll click on that. Okay, so hopefully you can see this. Okay, just start recording. What is the structure of the tick table? Stop recording. So this is using OpenAI's Whisper locally, rather than sending it across the wire to them. And here you can see it gives me the answer. So it shows me the transcription. What is the structure of the tick table? So it got that correct. And then it says the tick table has the following structure. And then it describes that to me. Okay, the fact that it's got symbol, timestamp, okay, open, high, low, price, volume, and that all looks correct. Okay, so that we can exit from here. You can see it very straightforward, super easy to get that working. So in the next version, and let's take a look. All right, so actually, let me just take a look. So we have visualize. All right, just run this one now. So this is a slight improvement on the previous version there. So again, just takes a moment or two to, and let's just minimize this, okay, so remove the distraction. So here you can see slight improvement, I would say. And I might ask, let me just find a question to ask it. What's the difference between the earliest and latest timestamps in the tick table? I'll use that one, okay? So let's start recording. What is the earliest and latest timestamps in the tick table? Stop recording. All right, give that a moment. And there we go. So the transcription is correct. Okay, let me just highlight that there. It's read my, it's transcribed my words correctly, and it says the earliest timestamp is 6th of November 2023, and the latest timestamp, okay, and that's 11:06:35, and the latest timestamp is 2023 11:08. That's today 9:45:54. Okay, it's just down below here. There we are. So that's done correctly. So this just shows us the kind of real-time audio waveform. So again, let's just exit from there, and then let's just look at the final example. Okay, and this one kind of takes it one step further. And this one actually does speech as well. So I'll turn up the volume on my laptop because sometimes the sound is not great because it's running through the virtual machine. So let's just minimize all of this to get rid of the distraction. And let me turn the sound right up. Okay. So hopefully you should be able to hear it. I apologize if you don't, okay? But if you run this yourself, you should be able to see it works well. And again, let me pick, let's have a look. What we could say is we did, I think, was it the worst performing stock or the best performing? We could ask it, what's the worst performing stock? All right, there we go. What's the worst performing stock in the tick table? Stop recording.
The worst performing stock in the tick table is FTR with a price of 3.28.
Okay, hopefully you're able to hear that. So again, it did the transcription correctly. And what I found is that with the Whisper library from OpenAI, I mean, there's a couple of models that you can use. I use the kind of the intermediate one. It's neither too big nor too small. And what I found is that particularly for the English transcription, it does a very good job. It seems to pick up my, what I'm saying correctly, does the transcription correctly. And again, this is just sending it across interrogating the database, bringing the results back, and then the speech part at the end is just a, kind of an extra thing. You don't really need it, but it just shows you what's possible. And for some applications, for example, for people that may have, may be visually impaired, for example, at least you can ask the question and you can get the result back in sort of English in this case, or you could choose another language. So other languages are supported as well. So I think the best languages that are supported are things like Spanish and English, for example. And this is, again, all documented on the Whisper GitHub repo. Okay, so let me just switch back to stop sharing this. And again, just wrap up with a couple of slides. Go back to the window here. And we'll just finish off here. So as you saw there, we looked at the couple of simple examples. So we're streaming some tick data in. I've got some sentiment data stored as well. Some improvement there needed. Very, very easy to use this LangChain SQL agent. Okay, you can see a couple of lines of code, and essentially you're not asking in SQL anymore. You just can do so in English. OpenAI's Whisper, pretty awesome stuff, and it's free. I mean, that provides, I think, some really interesting possibilities. I'm running it locally simply to avoid any kind of delay. The thing is that you can, in the code itself, it's possible to swap out the local install that I'm using with the call to OpenAI directly, if you wish to do so. Bear in mind, though, that it will cost money to do so, okay? So it's a service that they charge for. So you have to pay for that versus the local install, which is totally free. So that's something to bear in mind. And again, you can see that, with the kind of elements that I've shown you, you could very easily build a much better kind of chatbot for this kind of fintech questions and answers. I've just shown you some rudimentary examples and what's possible. You could take this a lot further and build something, even more awesome. Okay, great. Thank you. So let me finish off there. So I think, Benny, over to you, sir.
Yes, it's me. Hello again, Akmal. Thank you so much for the talk and enlightening us in these topics. And as we have some minutes left, I would say let's jump into a quick Q&A.
Yeah.
If you're ready. And maybe let's start with, you already talked a bit about SingleStore during your presentation, but you as a technical evangelist, I'm very interested in what is this exactly and what are you doing at SingleStore?
Nobody knows. I'm just kidding. So essentially, my role is I focus a lot on education. And so what I try to do is I build demos, I write articles, I do meetups and conferences. And it's really to try to educate people, help people understand the product, its capabilities, and the sorts of things that you could do with it in terms of the applications that you can build, how you can best utilize its features and capabilities. And these are kind of practical things as well. So today, for example, you saw, okay, it's a very, very basic in terms of fintech capabilities, simply because we're constrained by time and resources. Nevertheless, that's a great starting point. Anyone could take this stuff and you could run with it and build something even more awesome. And so it's really trying to help the developer community. Remember, we talked about the problem faced by a lot of developers today is, what should you learn? And where should you spend your time and effort? And that's a challenge because there's just so much tech out there. What should be the half a dozen or dozen technologies that you as a developer should be focusing on and learning so that you can improve your current prospects, or if you're looking for a promotion or the next great sort of opportunity in terms of your career development. And so my goal is to make that task easy for developers by building the resources so that when they want to use this product or some, build an application, there is something there that they can take and use straight away without having to invest too much time or effort in terms of learning, the nitty-gritty details. So that's really what I do, Benny.
But very interesting. So also very, very important job for every company, I would say, that employs developers, since you can't learn everything that's on the market right now, not in one lifetime. So thanks for sharing this with us. And let's jump to some other questions. And well, the first one are actually two questions. I will read it to you. What do you think is the future of AI, and what's your favorite project that uses AI?
Okay, so I think the future of AI, I know in the UK, for example, our Prime Minister has recently hosted this AI conference. Elon Musk attended, and other luminaries as well. And so I think there's a great discussion and debate around where this is going. I am one of those people that's kind of less concerned about the fact that AI may eliminate us. The species we may, it's the kind of Terminator type of scenario. I don't think that's going to happen, simply because I think at the moment, the checks and balances that we have in place are pretty good. They can be improved, but as AI improves, and exponentially it will, and get better and more knowledgeable, I think, building in those safeguards, that's the priority. But I think already we're seeing the practical benefits of it today. So the simple LangChain example I showed you means that, someone with very rudimentary knowledge, couple of lines of code, and you can be communicating with your database system in plain English. I mean, that's a great example of you don't have to skill yourself up in SQL particularly. And so that's one simple example. Another great example that I see in the field is, for example, doctors who use these intelligent assistants. So they're able to, provide information about the patient, various symptoms, things that they're observing, and maybe the doctor, he or she has a particular viewpoint, or maybe they have some thought about what may be the diagnosis, or what may be the illness, for example. But the AI can interrogate far more data. It may come up with other information which perhaps the doctor didn't think about. And that can be a great aid. So where I see this is becoming much more of an aid to help us do our jobs better. And again, if you look in the sort of GitHub space, Copilot, things like this, for example, great tools for helping us do our job better as developers. I was not a big user of ChatGPT until earlier this year. And then I find, even though I don't use the paid version of it, nevertheless, often, maybe I use it in the wrong way. Perhaps I should be using it more like Google, for example. But often it gives me great insights and, helps me solve some of my coding problems much faster than I might do just to spend the time on it. And I think the future, I think, again, where it's going and what should we be focusing on today, so definitely look for the likes of OpenAI, for example, and its equivalents in AWS Bedrock. Google has something as well. So these technologies are kind of emerging and coming up. And I think this is something really worthwhile for the developer community to be looking at this much detail, get the hands-on experience, learn what's good, where it can be applied. And I think, this is the direction that I would strongly recommend.
Thanks for sharing this with us, Akmal. And yeah, I'm totally with you. Apocalypse by AI. It's interesting to watch in Terminator or the first Matrix, but more of a concept than a real life example. Thank you so much, Akmal. And let's jump into the next question. What tips would you offer to developers and FinTech professionals who are new to the AI field and want to incorporate OpenAI into their projects?
Okay. Yeah, great question. So I think the best thing I would recommend is that, specifically if you want to focus on OpenAI, go and educate yourself on OpenAI. They have some great documentation, the APIs, all of that. There's great discussion forums as well. It is a rapidly changing and fast-moving space, so keep your eyes open. Already, I mean, I've seen issues with it today because some stuff that I had previously that was working is now broken. But that's my problem, okay, and my fault, something that I will resolve. But I would say just track the company, take as much online training as you can get. Lots of great places. Deeplearning.ai, for example, is a great place to get lots of free training on OpenAI. There are many free courses that they've been running over the past couple of months, by the likes of Harrison Chase of LangChain, for example. I think he's got about 3 courses on there. And this is a great way to educate yourself. learn about it. And then I think look specifically in the fintech space, look for where this might help you in terms of problem solving. You saw one or a couple of simple examples of that today, but I'm sure that if you work in this space already, you can maybe be able to identify areas where it can help you do your job better, or maybe something that can help your customer, interrogate your data or be able to make these important decisions. One caveat that I would add is that hallucinations is a problem still with this kind of technology, in the sense that if you ask the stuff of the AI, sometimes it comes up with answers that are you wonder where it gets the results from. But if you are quite precise, concise, focused in terms of what you're asking it, and you saw in the example that I set this variable called temperature equal to 0, meaning give me a deterministic answer each time rather than trying to make it up for yourself. I think those will be the things to keep in mind. So I think lots of scope within fintech. People that work in this space probably have got far better idea than I have. But I think keep your eyes open, look for opportunities where this could really, really help and be a kind of an intelligent assistant.
Thanks for that answer. And we have time left for one more question. And let's take this. Who is the data provider for stocks, and what is the number of and extent of tickers available?
Okay, so that's a great question. So the data being generated for that Kafka feed is entirely synthetic, okay? It's just a program. It's not coming from anywhere. This is a program that's generating these sort of fictitious numbers. There's no source for it, okay? So that's why I said be careful, because this is entirely made up data. So do not use this, please, for any financial decisions. If you have access to a real feed, and there are companies out there that can provide this service to you, where I think you have to pay them a fee to be able to access real-time data that's coming from the financial world, by all means, I mean, you could use that as the basis for this as well. But for this particular example, the Kafka that we provide, the broker that we have, is just there's a program generating these numbers, and it's a great way just to write some code, just to test it out, see the performance. And I think that would be a good use case for this. And again, please don't use these for making any financial decisions.
Okay, very wise words. Thank you so much for sharing this with us, Akmal, and thank you so much for the talk. I'm also very glad that you decided today to get up that early for us. Thanks for that.
Thank you very much.
And yeah, hopefully you enjoy the rest of your day, and see you soon, Akmal. Bye.
Thank you very much. Bye-bye.
All right, and before we jump to the next speaker of the day, just a few second break. And right back to FinTech and the second speaker of the day. He is lead developer internet banking at ING Germany. He focuses on improving development speed, which coincidentally perfect correlates with his passion to evolve and modernize software. And with his nearly 2 decades of experience in developing enterprise applications, he certainly knows what he is talking about. Welcome, Hans.
Oh, welcome. Thank you for the opportunity to talk here.
Thank you for joining us, Hans. All right, Hans, before we start with your talk, maybe you can wrap up your topic real quick for the audience and me, what we're going to learn from you today.
Yeah, what you can learn from me today is perhaps have a little more fun on the long run. When we are talking about new technology, about new things, new features, you think, oh, it's only fun to apply it. But in reality, You have to integrate it with the existing systems, the legacy systems. They work as they work, and often do have more focus on the legacy systems and the problems that they imply, and to focus on a new technology. And that's the reason why I want to talk about the existing systems, about maintenance, what you can do for your own project to make your life easier, and to be more able to implement new features. And this aligns to modernization. And I think it's a big thing in the financial industry, because financial industry was one of the first industries that used IT heavily. And so there are a lot of old systems, a lot of established processes, and the requirements are hard. They must be highly available, so it's hard to change. And I think it's a big challenge as a developer in such an environment to do something like software modernization. And yeah, that's the reason why I want to talk about it.
Perfect, Hans. Yeah, making my life much easier. That sounds very promising. So you got my full attention and that of the audience also, I would say. Without further ado, the stage is all yours, Hans.
Okay. So one moment, I have to switch my presentation. Okay. Often, if you do some things in legacy systems, it feels like being caught in a spider's web, I think. It feels, and you don't feel like a spider, you feel like a captured insect in the spider's web, because there are so many dependencies. You have to know the systems, you have to know how they interact, you have to know where's data stored, you do have to know the data model. There are a lot of processes running, and you have a lot of dependencies. Let's assume an operational dependency. I need a new JDK. Okay, you just ask, is this JDK available? Okay, we plan to make it available in 6 months. Okay, it's a little bit too late for my project, so I have to decide to use an older version of Spring Boot, for example. Or, okay, I need something like monitoring my systems in production. How can I realize that? And just talking to people, and they tell you, okay, it's a little difficult, but if you use our Chaudhri stack, you get it out of the box. You have to get the same information when you're talking about, I need a database. It's a little bit difficult, but get it out of the box if you choose our Chaudhri stack. And then you decide to wrap your Spring Boot application into a war in a year and deploy it on a Chaudhri. And that's what I think every developer knows and experiences every day. If you try to implement new things, you're caught in this existing system, in these processes, in these dependencies, and this makes life often really hard. As I'm a developer, the question, is it possible to avoid dependencies? Okay, it's a rhetoric question. Of course, it is not possible. But the question is, why do such dependencies arise? What's the history of it? What happens? And as I'm a developer, I just say, okay, I make an example. Let's start with a new project. Assume we have to implement the internet banking again. It's on a new technology. That's what I experienced when I joined ING DIBA about 12 years ago. It was the rewrite of internet banking, so it's a good example for me. What do? You start with something like core. You identify the components that you need. It's for internet banking. Okay, you need some UI components, some input fields. You need a navigation. You need a representation of the logged-in user. You need a list of accounts that you can access. And yes, you try to build it in something like a core element for reusable elements. And then you start implementing use cases. I assume it's something like payment use cases or brokerage use cases or something like that. And you use the things in core, and the first things that happen is you will experience that it's not sufficient what you did in core. You add some extensions and you think, okay, perhaps some refactoring could take place, but it's only a small hack just for module A or module B in this case. So, okay, it's okay and it works fine and you did your job. Yeah, and then you start the new module. Let's assume something like administration. Yeah, addresses, taxes, and so on. And then you find out, okay, there's some code that is only used by some modules, not by all modules. I will extract something like common. Yeah. Okay, I need common also has a dependency on core because I need something like the counts, the list of accounts and the logged in user, but it's better to structure it like that. So the process continues and you have reached about 80%, and then somebody came up and says, okay, we have delayed some aspects. We need something like we need something like tracking, web tracking. Yeah, we have to find out how the people navigate on our web page. Yeah, we need something like journaling. Yeah, police sometimes requests, and we have to give them some information. We cannot give them a technical log. We have to write a condensed form. Of course, we have some things like consents that have been given, and yeah, it's clear. Yeah, it's central things, and you implement it in core, and you add some things in core, and as you don't want to modify all use cases outside, we've implemented a lot of use cases. Yeah, you really decide to make the short way. Extend some base classes in core. Yeah, you add some dependencies. You don't realize. In fact, you don't realize how many dependencies you add inside core, and it's really growing up. Yeah, and then you start implementing the hard 20% use cases. Yeah, it's a typical thing. Yeah, what do you want to do? You just try to delay the hardest things. It's a new technology. You have to gather some experience, and so you start with the easier things, with the things that have to be long in testing, the most used use cases. Yeah, payments and brokerage. Yeah, this must work. You must not implement it as the last use cases. And so use cases like opening. Product openings, they are implemented last. So, and they are really complicated because they have dependencies everywhere. You have to ask for the address, you have to ask for tax things, you have to need some information for payments and so on. So they just address a lot of things. And as the process has to be, the project has to be finished and timeline is running, you decide, okay, we just reuse, we add some dependencies to other modules, and we just reuse things that we have already implemented. Yeah, and in the end, just have a look at it. Do you see the spider web? Yeah, I see it. Nah? Everything connected with everything grouped around a big bubble. A lot of things inside core that should be a lot of integration inside core. You realize you know it. It's hard to maintain, but you accept it, and it's okay to accept it. You know that you have finished a project in time. Yeah, they are all lucky. It's working. You can go productive. But if you're honest, you should think about restructuring the whole system, because it's really a maintenance hell. And there are so many dependencies. And if you have a deeper look at it, you've tried to structure the system. Yeah, it's not that you have done all things in one pot. And you've tried to structure your system, and the dependencies are a result of this restructuring. But if you're honest, your structuring is not very well. You should restructure the whole system, and especially you should restructure core, because in core there's so much functionality, there's so much grouped around, and so much reuse, and that's what I call them a black hole. Yeah. Such things like core, where so many functionality is integrated, so many responsibilities, such a broad API. Yeah, and as it is the starting point of our project, so many hacks are implemented, degenerated API. Yeah, and this leads to a situation that you sometimes don't know how the system really works. You have to debug into core often, because some unexpected things happen. A lot of usage about it is required. And that's why I say a typical thing is it's for experts only. Yeah, it's a constant point of interest. You always have to search inside it. And to be honest, there's a lot of technical debt inside it. Huh? And yeah, you have to accept it. Yeah, the option is to say, okay, the project must be delayed for an additional 6 or 8 or 10 months, because we have to clean up. Nobody can accept it, and it's not what you want to do. So the real challenge is that your project has finished, and you know there's a lot of technical debt, and you have to clean up. Yeah, and that's what often not done. And you pay later for things that you do not clean up. Yeah, and I took an example for a software development project, but I think you can apply this pattern on systems also. Yeah, I mentioned this operational thing. If you take our JBoss, you get so many things out of the box. Okay, they've really packed everything in one part. Yeah. And this adds so many dependencies. Yeah, all things are high integrated, but they make you use some things that you don't want to use. Yeah, and that's a kind of dependencies that I don't like. And I made a good experience with it, just to look at such black holes. Yeah. And you can easily identify them. In fact, a lot of things are integrated, and you've got a lot of dependencies. And yeah, you switch back. You can also give dependencies a value. You know, it gives me a value because I reuse something, but it implies costs, because if I reuse it, if I want to change this code that is reused, I have to address everybody who's using it. So the quality level should be high, so that I don't have to change the API too much or too often, and that it's clear how to use it. And that's what black holes don't fulfill. Yeah. Yeah. So I just want to show how we address this. Is an example how we address this in the internet banking. Yeah. In fact, we killed this core element. I moved out everything. Every aspect was moved into a library. Clean API was established. These libraries can be built for their own. And we have now 14 modules in the internet banking that can be built separately, that can be deployed separately. What we did not do just now, because we just put it all together in the end into one running deployment, but that's a detail. And we just focused on restructuring the whole system. And now I give you an example for one task. It's an interesting task, how to eliminate things from something like core, from the black hole. Yeah, we started implementing the internet banking from scratch, replacing the old with new technology. It was wicked. It still is Wicked. It's a Java-based system based on Wicked and Spring. Yeah, so I have to mention it. Yeah, and if the typical thing is how do you configure your application? And in the old system, there were two systems available. Dependency on a config repo. It was a proprietary development of ING developed in the 90s, end of 90s. So modern that time, but not modern now. For config repo is for static configuration. Yeah, it's a complicated system, not easy to use. Okay, very powerful. On the other side, we had some dynamic configuration. We required some dynamic configuration, but we had only dynamic configuration just for locking some use cases. Yeah, you have a problem with a database or with an external system, for example. Yeah, you not only depend on your own systems, you also depend on external systems. And if some systems don't work, you have to lock the use case just within a short time. There's a production problem. So you tell the customer, okay, the service is not available, try it a little bit later. For this scenario, we had a separate configuration, and we just had some two services inside core just for configuration. And configuration is used everywhere. Yeah, it's used everywhere in your system. And for every use case, we had to mock the services in tests. It was really not nice, and it's not a good thing. Yeah, because configuration in this way is not made for the future, and we have to use something more modern. And what we wanted to achieve is to switch to a Spring Cloud config server, to use the Spring Boot constructs for to configure our application. And yeah, you have a running system, and you cannot do a big bang thing. Yeah, everywhere. Yeah, so you need a plan, and that's what I want to show. First step was, I wrote an adapter for the Spring environment. So all entries in this database for configuring which use case is locked were made public to the published to the Spring environment and became properties. Yeah, so you could read a property from a Spring environment. It said true or false. Yeah, is use case is enabled or is not enabled. And then we introduced an annotation. It was not implemented in core. It was implemented in a separate library, also based on Wicked. So we could annotate each use case, the classes, with this property. And the property was then read during runtime from the Spring environment. And so we controlled if the use case is available or not. The nice thing is the service could be eliminated everywhere. Yeah, no requirement to mock it in tests or something like that. Just write this annotation, a clean, simple API to achieve this requirement. But on the other side, we had to go through the whole code and remove this service. And this was so much effort, really, but it paid off in the end. Really, it paid off. On the other side, we had the configurable thing. Yeah, if you want to use everything in Spring environment, you have to decide how to do it. Yeah, we decided to introduce configuration properties. Yeah, it's also a Spring-based thing. The logic is in a third-party library. And we decided to switch to configuration properties. They are also read by the Spring environment. And then we introduced the Spring Cloud config server. Yeah, we just changed the implementation of the service. So it just read things from the config repo and then it changed. It read the things from the Spring environment. After that, the same with the other servers. Remove every usage. Yeah, switch over to configuration properties. Was a big refactoring. Yeah, a lot of work, took some time, but in the end, every every usage of the servers was replaced, and we removed the servers. And then we enabled the refresh feature in Spring Cloud Config Server, so that we could were able to log our use cases on demand. Just change the configuration, trigger a refresh, and the system is reconfigured. And that made it possible to remove everything else. And as you see, it was a long-running process, but with a real plan, several steps that have to be taken, and the system was really simplified. Core things were eliminated. Use things from libraries, so just improved the architecture of the internet banking massively. Yeah, a really important thing is it's a really long-running process. You have to do so many things, and you have to have a plan. You have to do one step after the other. It took about 2 or 3 years from the starting point. Yeah, just to give you an impression, because it's not the only thing that you do. Yeah, you do it if you have time. If you change something, then you do it in parallel. So it was a really long-running process. Another thing, the example that I gave you was what I can do inside my application to make my application better, to remove dependencies, to reduce black holes, but you also depend on other systems in your company. Yeah, internet banking, you need backends, you need databases, you need something like an email server for sending some tasks. You have Kafka for sending messages, for informing other systems. Yeah, you have a logged-in user, you have a dependency on OpenAI Connect server, you want to realize file uploads, so files have to be checked before they are accepted for the company, so they can reach the internal network. So there are so many services that you use, servers that you use, and yeah, it's often a problem because you depend on the system, you need them, but not only you need the systems, you also need the test data. And test data, it's so complicated. Yeah, not the common cases. The common cases are fast, it's not a problem, but the special cases are really a problem. And so I just chose to do the following way. One moment, please. Just chose the following way. I cut every dependency. Yeah, really cut it and replace it with mocks or other systems. Yeah, I want to show it like this. Really, the internet banking, we replaced every service with mocks. For databases, we used an in-memory database. Something like an SMTP server, you can provide some provider. Can implement some providers that make it possible to serialize the send email on your local storage. So it's easy to test. Yeah, just make the use case. You see the file, how it is serialized. You can take the file and open it in your email client and you see if it's correct or not. Yeah. So we just mocked away everything. And it's interesting. We called it box. It's really massively used during development. It makes us independent from all test systems, environments, everything. If we need a special test case, special test data, we can mock everything. We did mocks respond with the constellation that we need. So we can implement, we can test in our internet banking, and don't have to wait for test data. Yeah, don't have to wait. Don't have to search for them or to wait or something like that. And in the end, it's possible to implement or to program without any connection to the internal network. And that's what I want to show you. I'm not in the ING network, and I've got a running boxed internet banking. And so now I have to switch my presentation. So starten. Sind hier so, okay. It's not working fine now. Okay, here we are. Okay. Just open, this is just what customers do. They type in I'm banking ING.de, and you see they are redirected to another service, Access ING.de. It's an OAuth OpenID Connect server. And yeah, if I just open my local running system, you see, okay, I'm redirected to an OpenID Connect server that just is for development and test. Yeah, and you see the headline, and it offers me the opportunity to log in my customers. Yeah, you can see everything is rendered. You can use every use case. You can do a transaction. Yeah, you see everything is working. For example, here you want to get an approval for your transaction. Yeah, this is mimicked. Yeah, simulated. And yeah, what also happens? No state change. Okay, it's exact the same amount. Yeah, nothing happened. There's no backend system involved. All responses are mocked, and this makes it easy to replay use cases, to test use cases, to does they work. You can mimic every special case. Our messages displayed correctly. Our testers like it because they can write automated tests. Every time they log in, they found the same information. It behaves always the same. You terminate the session, and it is the same again. Yeah. And this mock box also allows to implement some mocks that have some state change. I can show it to you. For example, to give back a transaction. Yeah. For example, this one here. Press. You want to have the money. Yeah. Wait a moment. So, okay. The approval is mimicked. Yeah, you go to Umsatz and say, hey, and you got the money. Yeah. So the mock is really powerful. It's a mock system that we implemented. It's really nice. You can easily add test data if you require it for your implementations. And yeah, I think it's a cool showcase. And especially, I'm not in the network. Yeah, every system, the internet banking depends on, is mocked away. I have synthetic test data. I really like synthetic test data. Yeah, I hope you enjoyed this showcase. So now I have to switch back. Is this one? Yeah. So was it switched back correctly? Yeah.
Yes, everything works.
Okay, so I'm back. So this is a small showcase what you can do as a developer to make your life more easy. It's really fun, yeah, to be independent of other systems, to concentrate on your own system, on your own development. Makes it easy to deliver things fast. Yeah. If I'm talking to backend developers and we need new services, new interfaces, and so on, I just tell them, give me the API. Just give me the API. We'll just talk about the API. And they say, okay, then we define an API. So I take the API, implement everything I need. I can prove if the API really works, if I've forgotten some things, if it feels good. So I can give immediately feedback. And often we are faster than the backends. Yeah? We are ready with our implementation, and the backend developers are not ready with the implementation. And that's not a typical thing, yeah? The typical thing is you have to wait until the backend people have implemented something, and in the end, you're the internet banking that uses these interfaces, and process line is running, and you have short time, and everything has to be hacked. No, everything under control. You have enough time. You are the driver. Yeah, it's a real comfortable thing. Yeah, what can I say about documentation? Experiences, if you just maintain the system very long, yeah, for me, it's nearly 12 years. Documentation is really hard, yeah. Some people say you have to document everything, but everything is it's something like it's placed on a heap, it's just stored. You don't find it. It's a lot of documentation. You have to search. Documentation outdates, and my experience is keeping documentation in sync with your system. It's a challenge, and you don't have the time, you don't have the person, and if you then require the documentation, you do not find anything. So just writing documentation so that documentation exists is the wrong way. Yeah, but what really helps is if you document some basics, some very important things, so that it helps you to understand the code. Yeah, I say the truth lies in the code, not in the documentation, and the documentation must help me to understand the code. And you should write it so that a third person that starts you can give him the documentation. It helps these people to the developers to understand the structure, to understand how the system works, how the architecture is, and that's all what you need for documentation. And you should focus on this. It's really what I can tell you. And what's really important, this documentation must be of very high quality. Yeah, just invest time in documentation, but really focus on the documentation, what you write. Yeah, that's what I can say about documentation. Yeah, and then some remarks about modernization of software, or what my experiences. Yeah, I focus on the black holes, because if you eliminate them, everything becomes really better. Yeah. But your resources are limited. Yeah. People, time, projects running. So you cannot do everything. Yeah, that's really important. So you always have to focus. What do I do? For example, we just use EasyMock for JUnit tests. Yeah, EasyMock is really outdated. Yeah, and I had a discussion with the freelancer who said, "No, I don't use EasyMock anymore. I want to use Mockito." Yeah, and I told him, "No, we use EasyMock, and you use EasyMock also, because the problem is, or well, not the problem. EasyMock fulfills every requirement. The experience is there. Everybody knows how to use it. I have no, I have no profit from moving from EasyMock to Mockito. Yeah, and there's no requirements. There are no workarounds, so it's okay to use it. Yeah, for the things that we use it, and if I just introduce Mockito, I have 2 mocking frameworks. Yeah, and this is more complicated than to have 1. Yeah, and if I replace with Mockito, in consequence, I have to replace everything. Yeah, and that's really important to know. It's not done by introducing something new. It's only finished if you replace everything of the old one. And that's what I showed in my example before. We had to replace every occurrence of the usage, every usage of these core services before we could remove them. And the system was only modernized after replacing all old things. And that also applies to this thing. It's sometimes okay to not to modernize, really to decide, no, this is kept, because the implication is I have to rework everything. And what do I profit? What's my value to replace it? And if the value is not high enough and the effort is too much and it's not a real problem, yeah, you can keep it. I also was asked a short time before, why, you've modernized everything, why do you still use Wicked? It's the same argumentation, yeah. It's perfectly matching our requirements. Yeah, after people that are able to use it, we have a lot of experience. A lot of things are solved easily because we know the technology. We know how. We know a lot of tricks. Yeah, a lot of things, APIs that are not commonly well known to a lot of developers. And if I have to switch to another framework, I have to start again. Yeah, and in fact, I have to rebuild the complete internet banking so that it's switched to a new technology. Because as long as I use Wicked, I need Wicked know-how. Yeah, so in fact, I have to rewrite the complete internet banking if I replace this framework on the long run. So we just staying on the Wicked, but. And that's what I want to tell you. Be prepared. Yeah, really be prepared. It's okay that you decide that it's now not the right time to replace it, but there will be the time when you have to replace it. So do everything to make the replacement more easy if it has to be done. This implies that, for example, I have a real focus on that we use Wicked only for what we need it. Yeah, a lot of every business code has to be placed in the Spring Stack, and if I find code in the Wicked things, then I just favor place this code in the Spring code so that the layer becomes as thin as it could be. Yeah, and that's what you can do regularly if you refactor a use case. Every release we try to modernize some use cases to have a look at it. so that we have a continuous ongoing and modernizing and to be prepared. Yeah, and that's important. One of the biggest things to be prepared is that I just make this monolithic system, a system that consists of a lot of applications that interact with each other, so that I can start refactoring, replacing things in one module, and this does not require that everything has to be changed. Yeah, it's time for a small summary. What we really have to do is that we have to accept technical debt. Yeah, it's important to become productive, and I just want to compare it with if you want to buy a house. Yeah, you have to accept the mortgage. Yeah, you can. Yeah, the alternative is I have to save money, and when I'm 60, I can buy the house. That's not an option. Yeah, you want to buy the house, so you go to the bank and accept the mortgage. Yeah, and that's the same. Yeah, and you have to accept it. And yes, what you have to do is you have to pay it back. You have to pay back the debt. Yeah, and that's the same thing with software. You have continuously removed technical debt, because if you don't do it, you have a problem. Yeah. The situation is in software development, we are our own creditor and debitor. Yeah. But in fact, we paid with another currency competitiveness. If you do not remove the technical debt, in fact, your system will die. On the long run, it will die. Yeah. There's a good thing to look at dependencies, yeah, and to give dependencies a value and a cost. This really directs you to the correct place where you have to focus on. Yeah. So focus what you have to do, the big points, not the low-hanging fruits. No? A manager like low-hanging fruits. No, address the really important things. This will improve your system really. Then a really important thing is you have to be patient. Yeah, I told you the one thing, it was 2 or 3 years, and it's sometimes hard to explain. I have to do it. I have to invest time. It takes a long time, and functionalities added? No, there's no functionality added. So it's sometimes a little bit hard to explain, but as a developer, you know, hey, I do it in the right way. I make it more flexible. It will make my life more easier. The maintenance costs just decrease massively if I do this. Yeah, and you have to address this, and you really have to be patient. It's really important. Then you have to be consequent. Yeah, if you replace something, replace it everywhere. Yeah, because if you don't do it, you have 2 solutions running parallel, and you gain the worst of both worlds. Yeah, and you have just not made your system better. You have decreased the quality of your system. You have done something that, that speeds up the decrease of the quality of the system. Yeah, and then have a look what's coming up. Yeah, if you are prepared, it's a nice thing. I can give you a short story. The tracking library was isolated, but the quality of the tracking library was not so well. Yeah, not so many things happened. But I had a look at it and said, okay, I have to replace it. I did a rewrite of this library. The API was clear, so it was easy to maintain, to replace it. The test was fast, and I have modernized it. And half a year later, they requested me to do a fundamental change. Okay, we do it within a few days. I think it was what was the feeling that I have to do something, but it's because I cannot change, I cannot improve this, it cannot add anything to the additional features to the existing library. That was the the feeling, and that was the experience, and that was the decision to replace it, to modernize it, to be prepared if some things have to be done. And half a year later, they just requested me, and was easy to do. And try to identify things that could come. Be prepared. It's not possible to be prepared for everything, but it's a fault not to say I'm prepared. Other experiences, black holes are very resistant. Even if you are dressed to replace them and you tell everybody, there will be a project that needs some core functionality and they will add something. They will do the hack. As long as this black hole is not removed, it will attach new things. It's really fascinating to see how black holes are very resistant. Sometimes another thing happen. If you say it's redundant, it's always seen as this is not a good idea. But I think if you want to reduce some dependencies, if you want to kill something, if you want to restructure your code, sometimes it's really important to accept redundancy. And especially if you just copy glue code. I have so many glue code. I have 14 modules just, and the basic infrastructure for configuring some things like where's the tracking endpoint or something like that. It's just a copy. It's 14 times a copy because it does not pay off to introduce a new dependency to it's not too complicated. So really accept the redundancy. Just think about it. Sometimes it's worth to build a library for things that are used only 4 or 5 times. Because they are really complicated, hard to explain. But on the other side, sometimes it's okay to copy some code 20 times because it's just only a simple glue code. Why just introducing a new dependency on it? Really important. I've shown you invest in development tooling. Nobody gives you OAuth 2 server. For development, nobody builds it. If you say the team, I need a sandbox, it takes time. You need it immediately, and it's easy to build. A lot of development tooling. All your requirements for production, secure. No, of course, this development OAuth server is not secure. It just fulfills the protocol, but all requirements for security, it's development tooling. SMTP protocol just realizes on the disk. It's simple written. But you have to invest in this development tooling. You have to make it available. And in fact, the most power comes if you have completed your development tooling. If you don't need any environment, if you don't need external systems. You have seen that there are several things that have to be mocked away. Vendor lock-in. That's really a story for its own. Often you use vendor-specific statements, and it's really hard to mock vendor-specific things. So what I did is I replaced every vendor-specific things. It was especially SQL, Oracle SQL, and tried to find a solution. It's only built on Hibernate, and sometimes you need some refactorings that spread to the other systems. For example, I had a query based on the database link, and I had to hide this database link in the database. Just introduced a few, and that worked. Always you have to clean your architecture. You have to think how it is better structured. And this gives you a lot of control. And the most important thing is really synthetic test data. Synthetic test data is a blessing. My experience with synthetic test data is really, it makes your life so easy. Don't ask somebody to give you test data, just write it yourself. And it's so many time that you don't have to wait. It does not delay anything. And I'm really convinced of synthetic desk data. So a few others observations and thoughts. Yeah, I've talked a lot of technical debt, no? And you can see this technical debt, in fact. Yeah? You can see that a lot of IT systems of most banks, that they were initially designed for internal usage only. Yeah, and you can see it if you log in. You use the account number for logging in. Yeah, every other portal, every other front-end web page, you use something like email address or a nickname or something like that. And if you use the internet banking of most banks, you have to enter something like an account number and a PIN that was sent to you by the bank. Yeah, and that shows that the model is somebody becomes a customer and then he uses services. Yeah, and the identifier is the account number. When I was a young boy, my father went to the bank and showed his bank card, and then he got his account statements. Yeah, 40 years ago. Yeah, unbelievable now, but in fact, it's the same now. You show your card at the internet banking. Yeah, so you have to type your account number. And as you cannot show the card and cannot be validated in any other way, you have to enter a PIN. Yeah, and then you see it's a thin layer. There's a lot of things that have to be done, and I'm very glad that we addressed this problem at ING DIBA now. We use the account number also. We will refactor it. We will really build a better customer experience here. Will be a large project. Will address a lot of things, but I think it's really important to do it. I've just had a look at some competitors, and it's really frustrating. I found a bank, they have to enter 3 digits for a branch, 7 digits for your account number, 2 digits for your sub-account number, and then your PIN. Yeah. And you see the legacy systems blinking up in the login mask. Yeah, you know they support up to 1,000 branches. More is not supported. The account number, okay, as they have sub accounts. I think the account number is also the identifier for the customer. So it's a customer number, and they every customer can have up to 100 accounts. Not more is supported by this. By this IT system, and I think they should do a lot of things to make the things better. Yeah, it's also complained about the maintenance costs are higher than the development costs. Yeah, I think it's clear. Management does not invest in maintenance. Yeah, it takes time. You have to do a lot of things, and they accept that the speed of development decreases, and that's what I really don't like. I think the attention should be much higher. You have to invest so that you can change systems, that you modernize systems. That's what I think. It's also, I think the interest rate of technical debt is really high. I think my experience is it's higher than return on equity. Yeah. If I see something that I want to change, I don't have the time and say, okay, it will take about 5 days. I don't have the time of this 5 days. And then I go to the same thing 1 year later. I think it will take about 6 days. Yeah, this is an increase of 20%. It's very subjective. Yeah, it's not validated in any way, but it's feeling that technical debt has a real high interest rate, and it's really worth investing. Yeah, especially as it's not only investing. You have to be patient, and it takes time until you see the effects of your investment. Yeah. What also is when you have a well-maintained system, yeah, it's clear how it works, and then it's easier to migrate. But if it's well designed, the need to migrate it is not so high. So I think often people focus too much on technology instead of how good do the systems work. I'm convinced that a well-maintained COBOL system is worth a lot. No? Really, even if the technology is outdated, people are expensive, it's not so fast. But if the data model is fine, the system works fine, it's well designed, you always have the chance to change it. You always have to change to migrate it. If you really have to migrate it, a well-designed, maintained system is easy to migrate. So that are really investments, and I think it's worth mentioning it. That's what I think. Yeah, and to give you a small example, it was in the press a short time ago that the IT integration of 2 banks was finished. The takeover started in 2008 and it was finished in 2023. Wow, yeah, it really took a real long time. And I think this is really a warning. Yeah, it's not assume a car maker merges with another car maker and they take in the takeover process takes 15 years. Unbelievable. Yeah, and in IT, because it's massively based on IT, suddenly this is acceptable. I don't think that it's acceptable. Things change really rapidly. Yeah. There are a lot of competitors coming up that we don't expect now, but they will arise in a few years. Don't know. I think a lot of people or companies that use technology really hard will offer some new services in a financial way, and we have to adopt. We have to react, and if we don't have the time to react because IT projects take such a long time, I think this is a real threat for the business model of a lot of banks. So I think the timeline is really interesting. Yeah, occurrence of the iPhone until now, and nearly matching this IT integration. I think this is really a warning. Yeah, it's really saying invest in your systems, improve them, let them evolve. No? Don't believe in okay, if it does not work, we will replace it with a new system. This does not work. It's the same. You have to integrate with the system. So I say invest in maintenance, invest in your existing systems, try to structure them better, do it, and don't wait until you have to do it. Okay, thank you for your attention. I hope it was interesting for you. Some legal remarks. I used some pictures from the internet. I want to mention them. I want to mention the license. And thank you very much.
Hans, hello again. Thank you so much for the talk. So we are really low on time, but I would say let's tackle at least one question for the Q&A, if you're still up for it.
Yeah.
Yes, perfect. Then let's take the first one. What changes do you expect in combining new technologies with legacy systems? How can businesses prepare for these upcoming shifts?
Changes do I expect? A good question. The thing is, you don't know what a new technology brings with you. So you have to analyze what do I have to do. The only thing is that you can prepare your legacy systems. I mentioned something like batch jobs that deliver data late. This is really, you have to address it. You have to prepare for it because the new technology will be near time. The expectations of customers is near time. Yeah, so you have to address these things. Then it will be easier that new technology can be combined with legacy systems. Yeah, think what's coming up. Yeah, near time things. fast reaction. Yeah, I think something like opening an account, it becomes a pending state, is not up to date. Yeah, that's a real deep technical depth. And if you address this, it's easier to go buy new technology. Yeah.
All right. Thank you so much, Hans, for answering this question. And thank you so much for your talk and joining us today. Hope you have a nice rest of the day and maybe see you on another live day.
Okay.
Bye-bye.
Have a nice day. Goodbye.
Right. And before we jump to the next speaker of the day, just a few seconds break. And right back to FinTech and the next speaker of the day. He is Chief Dev Advocate at Aerospike. He's passionate about solving complex business problems by using technology and also educating people on how to best use tech to achieve their goals. His name is Tim, and since he's located in another time zone, he sadly couldn't make it today. But nevertheless, he wanted to be part of our FinTech Day, so he sent us a recording of his talk, a pre-recorded talk. You can also ask him questions via the info we will provide you in the chat. So yeah, I would say if everything is ready, spot on.
Hello everyone, welcome to my talk on leveraging real-time data in FSIs. My name is Tim Faulkes. My background is development. I've been an enterprise application architect for more decades than I care to admit in public, and I'm really passionate about building high-quality code, writing demos, and making the most use of the tools we've got available from the development perspective. What I want to talk to you about today is real-time data. Now, as I said, my background is development. And I know that typically when we talk about modern development, our application stacks look something like this. We've got application clients, which are web-based UI, something using React or Angular or something like that. They typically talk to mid-tiers, which talk to ELBs. And you've got worker nodes through Kubernetes, which have your mid-tier application servers running on them with microservices on them. These are scalable, these are well thought out patterns, and things that people are very, very well versed on. And as an application developer, you're used to these patterns and the importance of each of these parts of the pattern. As a developer, I'm also aware that we need a database, and we tend to give it scant thought. Typically, the database it's a necessary evil. It's something that's going to store the data and hold the data, but it's not super interesting to us because we're developers. We want to write fancy front ends or really cool microservices. But fundamentally, that database is incredibly important. And in the world we live in, that database is becoming more and more important. So we live in a world where more data equals better results. As we're moving into the AI paradigm more and more, we find that the better results come from more data. Now, these are some quotes from very large companies. So Google's research director, Peter Norvig, said things like, "We don't have better algorithms. We have more data. Simple models and a lot of data trump more elaborate models based on fewer data." That's about analysis. So that's about the data that we're using to train models. The more data we have, the better the training we can get. What about real-time decisioning? What if I want to load that data in real time and make a real-time decision? Well, if we look at PayPal is very, very advanced in their use of fraud detection through neural nets, and they are pioneering the way. And when they decide if a transaction that you're doing is fraudulent or not, they need to load a lot of data. The more data they can load in the same time period, the better the result they can get. So you can see some of the dimensions are on the screen. Things like they don't just look at transaction history. It's device information, email accounts, history, identity scores across different browsers and things like that. So there's a lot of information, and the more information they can get, the better result they can give in fraud. If we're talking about financial services industries, there's a lot of places where these real-time decisions that require vast amounts of data are very common. So I spoke about fraud detection. Credit card fraud is a very obvious one. It's going to be the focus of what I'm talking about today, but it's really not the only place in FSIs where you find the need for real-time data. If we look at risk management and assessment, is a particular trade risky in a stock trading application? You want to evaluate that in real time. Can we help people make better decisions with more data based on historical trends? Compliance. If I'm a margin lending company, I can't legally lend margin lending in the United States on penny stocks. But if I'm doing my validation on that requirement through, say, a batch job on the mainframe that only runs once every 24 hours, it enables people to do margin lending on penny stocks early in the day and trade and sell them late in the day and violate that compliance. You want to be able to do that sort of compliance far more frequently than what we are typically used to with batch processes, and so on. There's a good number of these places where we have to be able to make real-time decisions. And when you make those real-time decisions, the more data you can load in the same time period, the better the results. And if you can load them faster, then your analysis, your AI models that you can apply in real time have more time to run, so you can make them more sophisticated. And that gives you better results on your data. It's not just FSIs though. This trend of needing more and more data, being able to load it in real time to make decisions, is fairly ubiquitous across many different industry verticals. Almost every industry vertical has a need for, I need to make a decision, and the faster I can make that decision, the better. So it doesn't really matter whether we're talking FSIs or healthcare or sports or retails. There are very valid reasons that we need to make that decision really quickly. And typically, the databases we've been using historically don't cut it so much. So I want to talk about some patterns we're using and the sort of databases that you might use to make these sort of decisions in real time. When we look at systems, we typically find that people will measure latency and they'll talk about the average latency. The average latency basically says half my customers will receive this average latency. The other half will go above that latency. So if we say, I want an average latency of 10 milliseconds, and my 99 percentile is 1 second, sure, 50% of my users have got under 10 milliseconds, but those people who have gone over it can go dramatically over it. And what we typically find when we talk about latency, particularly in the database world, the importance of 99% or 99.9% is incredibly high, because you get this hockey stick effect where as we go up in those percentile ranges, and my scale on this chart is non-linear, it's got to be said, you get an exponentially high increase in latency. And that is really hard to handle. Now, if I'm loading lots of data, I'm doing a real-time fraud detection, for example, the more data I can load, the better. But if I load each of those pieces of data, each one has a chance of hitting that 99% or that 99.9%. And that's going to give me a really bad result. So when we go and talk about analysis of systems and performance, what we really want to talk about is the 95th percentile or the 99th percentile. Well, what does this actually mean? Well, the 99th percentile means that if I have 100 samples, 99 of those 100 samples have that value or less in latency. And the curves, as you can see, are pretty steep. You're trying to get up to that 100%, and 99% is pretty close. You want all your customers to have the same sort of experience. So how do we find out what the 99th percentile is? I mean, it's easy to measure the average, it's easy to measure the max, but to measure the 99th percentile or 95th percentile, typically what you have to do is get your results, sort them by time, and take the 99th percent. So if I've got 1,000 samples, I want to read the 990th, and that'll be my 99th percent. And the value at that sample will be my 99th percentile. That works really well for small data sets. But for large data sets where we're measuring hundreds of thousands of transactions a second or samples a second, that sorting, that cost becomes really high. So when I'm talking about 99 or 95th percentile in this presentation, typically what I've done is I've applied a mathematical model where we're effectively bucketing and performing linear regression of my samples so that I don't have to sort the data. I measure something, I put into a bucket. Those buckets are separated by powers of 2. So in my case, my smallest bucket was about 100 microseconds. Then it went to 100 microseconds times power of root 2, times power of root 2 again, and so on. So each bucket is power of root 2 greater than. I could have just doubled the buckets. And you can see on this graph, I've got that blue line, which shows the effect of doubling the buckets. It's a very coarse-grained effect, and it means you get more inaccurate results. By using the root 2 powers, I get the green line, which isn't perfectly accurate, but it's a very good approximation of that true curve we want to get. So let's talk about databases and how we're going to model the information. There's two different sorts of databases out in the world at the moment, the NoSQL databases and the SQL databases. As developers, almost all of us are used to that relational database, the SQL databases. Some of us have worked with the NoSQL databases. I've used both relational and NoSQL databases fairly heavily, and I want to spend a little bit of time comparing and contrasting the two. There's some terminology that we find different. So in our relational model, we have the concept of database. A database is a logical grouping of entities. So things like customers and accounts will typically fall into a single database. Inside that database, we have tables. A table is a logical grouping of a single entity. So it might be an account table, it might be a customer table, it might be an address table. Inside that table, we have rows. The rows are the actual level of information. And we have a schema. And the schema defines what does that table look like. It breaks it down into columns, and columns have a type, and they have things like, am I nullable or not? So in my example, you can see Bob hasn't updated at time. Joe doesn't. The record of Joe must have an updated at time, but it can be null. So it looks like it's not really there, and I can find out if it's there and not null. When I talk about NoSQL databases, in my case, I'm going to talk more about Aerospike, but some of these concepts apply across a range of different NoSQL databases. Typically, the records are unstructured. So as opposed to the structured data in a relational database where I have a schema which enforces each record to have exactly the same structure in the same table, each record in Aerospike is self-describing. I have a concept of a namespace, which is sort of like a database. It contains a set of tables, but it's also a bit like a table space. It defines the actual storage location. Are they going to be stored in memory? Are they going to be stored in Drive? That sort of thing. Inside that, I have sets. A set is like a table in relational concepts. It's a logical grouping of entities. I have rows, and a row is similar to a record in Aerospike. It is a single instance of the thing in that set. And like relational databases have columns, Aerospike has bins. So effectively, I've broken down a single record can contain multiple pieces of information. So things like a name, an email address, and so on. Now, they can be simple, like strings, integers, floats, and so on, or they can be complex. They can be things like lists and maps, and those can be nested hierarchially. Now, within Aerospike, because each record is unstructured, there's no schema across the set, each record is self-describing. The application, however, will normally enforce a schema on top of it. So it will say, hey, I'm going to store a person, and the person might have the sort of values you're seeing there. If I'm going to store an account, I'd probably put it into a different set. When we're considering a relational data model, we typically normalize the information. So we've got the different normal forms, third normal form, fifth normal form, and so on. So consider a customer. A customer has multiple addresses. Those addresses don't make sense outside of the customer. If I delete the customer, I want those addresses to go away. So I would create my customer table. I would give it a primary key, and then I'd create my address table. the address table would have a foreign key of the customer ID. And so that if I go and delete that customer, I want the addresses to go away. So I'll mark that to be on delete cascade. And the removal of that customer will automatically go and remove the addresses. When I want to go and load a record, and this is from Postgres, but the same thing applies in most other relational databases. The same sort of concepts are there. So if I go and read a customer, and I want to get all the addresses from that customer, I would define an index on the customer. Sorry, I would define an index on the address relating to that customer ID. And when I say select star from address where customer ID equals my past customer ID, it would go and read the index from the drive, scan through that index, find any records that match, go and read those records from the drive and bring them back. So if I'm bringing back 100 addresses, I'm doing a good number of reads from the disk. There'll be the index reads and the actual device reads. The probability of hitting that 99% or the 99.9% is increasing the more number of records we read. If I'm doing the same thing in Aerospike or another NoSQL database, there's different ways we can do it. But in this case, I want my customer to contain my addresses. It's an aggregation. It's not an association, it's an aggregation. I want to make sure that if my customer goes away, my addresses go away. Well, what I can do, because the addresses are a fairly finitely bounded set of information, I could actually go and store those addresses inside the customer object itself. So you can see my structure on the right there. I've got my customer and my customer details, but inside that, I've got my addresses, and the addresses contain the address detail. They're actually stored within the same record in Aerospike as the customer. That means if I delete my customer, they automatically go away because they're all contained in the same record. But it gives me some advantages. It simplifies my addresses. I no longer need an address ID or a customer ID. They're inside the customer ID, so why would I need a customer ID inside the address? It's already stored in the same record. When I go and read this, it's typically one read from the disk. No matter how many addresses I've got, it's one read. So it's a bit more optimized in that storage pattern. Now, relational databases these days typically have other ways of doing this. We can do things through JSONB, for example, which stores information in a JSON format, a document style format. They're fairly recent add-ons to a lot of relational databases, whereas some of the NoSQL databases like Aerospike have had this capability from day one. So it makes a lot of sense to be able to nest this information inside a current object. That works well if you're doing an aggregation. But what about an association? If I've got two top-level items that make sense in their own right, so a customer and account, I don't want the accounts to go away if I delete my customer. So I can't go and nest my accounts inside my customer object. What I can do is I can go and store the IDs of my of my accounts inside my customer object. So you can see I've now got a new field, the account IDs. When I go and query it, I can load my customer, and that will give me a list of IDs. Then I can go and load my accounts. And to do that, I can perform what's called a batch get. I've got a set of keys, and I can go and say to the NoSQL database, go and get me the 20 different accounts which have these IDs. And in something like Aerospike, you have multiple nodes, a cluster of nodes, and they will have distributed the data automatically for you around those nodes. Loading those records are done in parallel. So I might have 5 nodes, there's 20 accounts I'm loading. Each one of those nodes will probably have about 4 of those accounts. Aerospike is one single core from the developer side, batch read, go and get me these 20 keys, but it's smart enough that it will go to each one of those nodes, say, go and load me these keys that you own, and so on, and bring the information back in parallel. It's very, very efficient. So let me talk a little bit about Aerospike. One of the things that is slightly different between relational databases and NoSQL databases is this concept of the CAP theorem. Now, if I'm an atomic database like Postgres, like MySQL and so on, any of these monolithic atomic RDBMSs, they typically are both consistent and available. They run on a single node. Now, they might replicate to another node, but primarily the main database function runs on a single node. And that means that they can guarantee both consistency and availability, unless that node goes away, in which case they're just not there. They can't serve the data. You might have to fall over to a backup and start wondering about this distribution of data. In a distributed system, be it a NoSQL database like Aerospike, or even something else which stores state, you come into the concept of I need partition tolerance. I've got a set of nodes. What happens if a network breaks and suddenly my 10-node cluster becomes 2 5-node clusters? There's something gone on. I need to handle that partition tolerance. Inside NoSQL databases, they have to pick. They have multiple nodes, so they must be partition tolerant. The CAP theorem states that out of these 3 pillars, consistency, availability, and partition tolerance, you can guarantee 2, but you can't guarantee the 3rd. Now, we've got the concept of partition tolerance, so we've got that one. That means we must pick either consistency or availability. We can't guarantee both. And this is very easy to prove. If you look up Brewer's CAP theorem, there's very simple proofs of this. Most NoSQL databases fall into what we call an AP. They favor availability over consistency, so they guarantee availability and partition tolerance. It's easy to do, it's quick, but in financial services, it's really not what you want. You want to make sure your data is always consistent. So there's some databases that are both consistent and partition tolerant, Aerospike being one of them. And if you notice carefully, Aerospike actually is in both. You can actually pick and choose with Aerospike, do I want it consistent or do I want this data available? And in some use cases, you've got different use cases in the same database might need different sorts of availability. And with Aerospike, you get to pick and choose. Now, Aerospike's designed to be really, really fast. So these are a couple of graphs that came from our customers, and they're on big use cases. The first one is digital identity management, something that's very important in FSIs. If I'm transferring money from my bank account to someone else, I really want to make sure that it's me transferring the money. I don't want anyone else to be able to impersonate me. So digital identity management performs that check. And this is a very well-known digital identity management customer. They were using Cassandra and they had a big cluster. I mean, they're at 450 terabytes. They had about 200 nodes of Cassandra. When they moved to Aerospike, they dropped that. And you can see the latency curves. The original one was between 4 and 9 milliseconds. When they moved to Aerospike, their average round trip time was about 200 microseconds. And they increased the data volume, 1.3 petabytes. That's in production. That's a large amount of data. The other one is a very well-known online payment provider, and they're doing financial services fraud detection. They were using 2 Oracle RAC clusters. In front of that, they had 360 nodes of cache, a huge cache to try and get that performance. But even then, because of the probability of hitting that 99th percentile, they found that it wasn't fast enough. They found that even that huge cache didn't give them enough speed to be able to guarantee the right sort of latency for the end-to-end fraud detection. And so they moved to Aerospike, and you can see again that latency dropped from about, in their case, 1.5 to 2 milliseconds, down to about 200 microseconds. It's really fast, and then they scaled the data. They went from 10 terabytes to 100 terabytes of data. Both of these companies also reduced their server count very dramatically by using Aerospike. All right, so let's talk about credit card fraud detection. Now, I've done this with a good number of financial services institutions between banks and online merchants and things like that. And there's a lot of commonality. So I've tried to abstract that away into what we're seeing. So the first thing we want to do is look at business requirements. Because we're doing credit card fraud, most people have fraud detection algorithms. These are based on either rules-based engines or neural nets or deep learning models, some form of sophisticated rules that you need to feed data in to load that, to be able to get a deterministic view of, is this fraud or not? Now, one of these providers I was working with had a 120 millisecond window. So the moment you swipe their credit card to say, yes, it's fraud or no, it's not, you have 120 milliseconds end to end. Now, in that time, this particular customer wanted to load a lot of data. They wanted to load your most recent transaction history over 30 days, up to 50,000 records. For the average individual like myself, you're not going to get anywhere near 50,000 records in 30 days. But for some of the large customers they're working with, that was fairly easy to do. Imagine being a large corporation with a very large number of corporate cards. You can get those number of transactions very easily. The more data they could load in that time, the better the result. the quicker they could load that data, the more time they had for applying their fraud detection algorithms. And so they wanted to do it as quick as possible. In their case, they were processing about 1,500 transactions a second, but they needed to scale up. They needed to scale up to over 10,000 transactions a second. So that's the problem we're going to talk about. In their case, they have a credit card. A credit card has one or many transactions. I guess it could have zero, but obviously fraud detection on zero transactions is fairly easy. So how would we model this in a relational world? We basically have a requirement where we want to get the transactions between two dates, limit of 50,000, ordered by date. So in a relational world, I would have two different entities. I would have a credit card entity and a transaction entity. The account number on the credit card is the PAN, and so I'm going to use that as my foreign key. So I'm going to have a PAN on my transaction, and effectively I want to say, for this PAN, give me any transactions in this date, the latest 50,000, the most recent 50,000 of those. Fairly simple. We're all fairly used to that sort of modeling, I think. Now, in order to test this and allow people to play with it, I created a testing application. This is entirely open source. You can see the link there. And it allows you to play with different databases. It allows you to say, I want to play with this database or whatever. So let me show you an example of that. So I've got a fairly beefy server. It's not my laptop, but I'm running this simulation on that. So I've set up two different connections. One is Aerospike and one is Postgres. So I'm going to pick my Postgres database, and I've loaded some data in there. So I've loaded 15,000 records into my Postgres database, and it's a 16-core machine. So I'm going to give it 16 threads. And what this is going to do is it's going to simulate a transaction. So credit card swipes have come in, and I want to load them. I want to load the customer details and or the transactions for that particular card in as quick a time as possible. And so you can see that I've got the average percent, or in this case, a couple of milliseconds, the 95th percent, and the 99th percent. My throughput is measured on this bottom graph. Now I can stop that and start a different solution running on a different database, doing the same thing. So that's the application we're going to be used in this testing. At the moment, my application has only two databases. It's got both Aerospike and Postgres. But you guys probably have your own favorite database you want to play with. If you want to run the same thing, then it's designed to be very extensible. So I'm going to very courageously do a live coding demo and show you how I'm going to add Redis in. Now, Redis is also a NoSQL database. It's very fast. It's in memory. So sometimes it has scaling problems because memory is expensive. But for small workloads, Redis is a great database. Now, I'm running on a Mac, so I'm going to give you a demo on a Mac. I've gone and installed Redis. So I've already got Redis running, and my server is up and running. So what I'm going to do is I'm going to show you how to add this into that simulator. It's a Java-based simulator. And so let's go and have a look at that. All right, so I'm using my IDE. In my case, it's Eclipse, but it won't matter. I've got my application downloaded. I'm going to add a new class into my databases. So I'm going to add a new class in here. I'm going to give it a name of, let's call it Redis database. And then in here, I've got a couple of things I need to do. The first thing I need to do, I'm using Spring. So I'm going to mark this as a service so that it can be discovered. And the other thing I'm going to do is I'm going to give it a database. I'm going to say, I want to use this database. And I need to tell it a couple of things. I need to say what my name is. So we're going to call it Redis. And then something which identifies, in case you want different sort of workloads on the database, I'm going to give it a version. And I'm just going to say initial. All right. And that will give it enough information that that it knows how to use it. The other thing I need to do is I need to implement an interface. So I'm going to put implements database functions on a Redis connection. So if you're familiar with Redis, a Redis connection is fairly well known to you. It's the way you connect to a Redis database. Okay, now that's going to tell me that I haven't implemented a bunch of methods. So what I'm going to do is, the first thing I need to do is tell it how to connect to my database. Now there's a number of steps in this, so I'm actually going to copy and paste the code from another window. But when I connect to Redis, I need a few things. I need a host name, I need a port, and a password. And then this is basically saying, so once I organize my imports, this is the information I need. So that the application we have has a little UI, and it will interpret this information for the config items as what it's going to ask the user for. And you can see it's got some defaults and things like that. Once I go and test, it's going to come and say, I'm going to try and connect to the instance, and I'm going to actually try and connect to this instance of the Redis database that I need. That's all great. The only other thing that I'm going to need to do is I'm going to need to implement a method. So you can see that in this, I've missed some methods. So I'm going to say, go and give me all my unimplemented methods. In my case, I'm just going to, let's do insert credit card, this one here. All right, so I can go and save that and just store my data. All right, now once I do that, I'm still running, so I haven't actually updated I haven't stopped the application and restarted it. So if I go back to my browser, and this is just the one running on my local one, when I create a new connection, you can see that my database only have Postgres and Aerospike in there. But now if I come back into my Eclipse and I stop that, and then I restart it, if I then come back to my browser and refresh that, when I create a new connection and drop my database down, you can see I've now got Redis in there. If I select Redis, the version is initial, the version we put in there, and it's populated some of that information that I've got. If I hit save, I need to tell it what my config name is, then it will go and create that connection. I've got Redis server running, and it was successful. So I could go and start a workload, I could go and seed some data, and if I just go and put in 1,000 records, I'll just give it 10 threads for now, it's actually going to start working. So you can see that it's very efficient, didn't take much time, but it's really easy to add your own database in here. If you want to go and play with this and play with other databases, then it's really designed for that. All right, so here's the code in case you're wondering for later. So let's look at some results. So that's this workload, this credit card simulation workload, I ran on both Postgres and Aerospike. Now, my aim was to try and put 50,000 users in. Now, each one of those users had up to 1,000 credit card transactions over those 30 days. So even though it's 50,000 users, you multiply that by the 1,000 records, or up to 1,000 records, and we're in the millions of records. When I loaded Postgres, it was moderately slow. It took it over 24 hours to do my 15,000 users, so I decided to stop there. It's a good sort of number. All these tests were run on the same machine. So you can see the specs here. There's no difference, and I made sure that when I did these runs for this production, I stopped one database before I tested another one, and so on. So this was just my Postgres run. Here's the code for my testing drive. The inserts didn't worry me because inserts aren't a real-time nature. It's that credit card fraud that has that real-time nature that we really want to make fast and efficient. So this is the code for reading my credit card transactions. I've got an index on my statement where it's on the pan and the date descending, so it's in the right order that we want. And you can see it's a very standard SQL statement. If you're used to Java and loading data through a relational database, this code will look very familiar to you. You can see that I'm getting the data source. I've got a Hikari connection pool to make sure that I'm not recreating connections, all that good sort of stuff. It's really optimized as much as I can for performance. Now, as you saw when I showed you the demo running on that server earlier, it got pretty good results. So it's a couple of milliseconds round trip time on average. The 95th percentile also isn't bad. It's about 7 milliseconds. And the 99th percentile, the one we probably care the most about, is about 14 milliseconds. Remember, we've got 120 milliseconds end-to-end for that testing, to load that data. So I need to make sure I leave time in that window to make sure that I have room for my fraud detection algorithm to run. It's 120 milliseconds end to end, not just loading the data. So at 14 milliseconds is my 95th percentile. That's great. It gives me 100 milliseconds to run my fraud detection. If I look at my server, my CPU seems to be my bottleneck. I've got 16 cores on this node. That's why I set up 16 threads. If I actually pushed it harder, if I went to more threads, like 20 threads, I didn't get any more throughput. I just added latency because I got thread contention on the database. So that's good. My throughput's okay. It's at 9K. Remember, they're doing 1,500 transactions at the moment. They want to go to 10K, but more is better. So that's okay at the moment. But the problem with this is the steady state. I have a lot of memory on this machine. There's 128 gigabytes of memory. This is the steady state when all these records were loaded into the Postgres cache. Have a look what happened when I started. This is my latency originally. And you can see the numbers are a bit hard to read, but this number up here is 65,000 milliseconds or 65 seconds. My throughput, it's actually running, but it's so small that you can't really notice it. It was about 40 transactions a second. So Postgres would solve this problem if I could fit all my data in memory. If I can't, then I'm not going to hit my 120 milliseconds SLA. I'm not going to go close to hitting my 1,500 transactions a second, let alone where I want to get to at 10,000 transactions a second. So Postgres is really, really good for a lot of things, but these really high speed, low latency situations, unless you've got a lot of DRAM or a very small data set, it's probably something I would think twice about. Could I use Postgres, a relational database, for this sort of problem? It's really not what they're designed for. They're designed for those very strongly consistent multi-record transactions and being able to do lots of advanced things like joins and things like that NoSQL databases can't do. So I then want to try this on the exact same use case on a different database, in this case, Aerospike. Now, Aerospike also, similar to a relational database, supports secondary indexes. So I could do that sort of foreign key relationship using a secondary index. It would be exactly the same sort of model. I've got a transaction date, I could put a secondary index on that and go and load the records from that. It's a really simple model. If you're used to relational databases, then it answers the problem really well and it's simple to do. However, the secondary indexes on a NoSQL databases are designed for more scatter gather. I've got 100 nodes in my cluster, let's say. Each of them holds some of the records. I want each of them to go and tell me which records match my criteria and pull them back. So there's a lot of work the client does when I say go and run this index that is pushed out to each of those nodes. If it's a small set of data, then that's probably not as super efficient. Also, each of those records is a separate read from the drive. As I spoke about earlier, when you're reading that 99 or 95th percentile, you start getting that hockey stick effect. And so reading a smaller number of records is better. So when I ran it, my numbers were okay. Certainly not what I'd be very happy with. 10 milliseconds on average, 30 milliseconds on my 95th percentile, and a bit of variability, somewhere between 55 to 60 milliseconds on my 99 percentile. I'm only doing 600 transactions a second. So this, remember, on a single server. If I had a larger cluster, it would probably be better. But it's probably still not the way I'd solve the problem. One of the problems we face in both the relational and the NoSQL data model is that we're loading a lot of individual reads from the drive. Now, these are SSDs. They're fast. They're designed to be read in parallel and things like that. But sometimes it's better to put multiple records into one structure. So credit cards, for instance, credit card transactions. I want to store a lot of transactions in a day range. So instead of storing each transaction individually, what I'm going to do is I'm going to bucket them, like we saw with the addresses earlier. I'm going to store all the transactions for a single credit card for a single day in a single record. Now, that means that if I want to load all the transactions for 30 days, I can just load 30 records. I know what today is. If I want the last 30 days, I can work out those keys very easily. And therefore, I can go and perform that batch get and do that in parallel while I'm having each of the servers loading the records they own across a variety of different records and bring them back in parallel to my client. Now, because it's all done in parallel, that means that my worst case time basically falls down to the worst case of a single read off an SSD. And that's pretty fast. So to compare and contrast with the code we saw for relational database, this is my code to retrieve from Aerospike. And it's all open source. So this is all in that GitHub link that I sent or showed earlier. So you can see I've got my 30 days. I go and create a set of keys for 30 days. I go and read my record. So it's a single call. I've given it 30 keys, and it's going to get me 30 records. The fact that it's going off and doing a whole bunch of work behind the scenes and doing scatter gather across a cluster, bring results back in parallel, merging them together, that's all hidden from me. I then go and iterate through that and create my transactions. Okay, what does this look like? Well, it's better, a lot better. So you can see that my latency here, my average latency is about 400 microseconds. My 95th percentile is sub-millisecond. My 99th percentile is about 1.4 milliseconds. So, the throughput is about 70,000 transactions a second. So by changing my data model in a NoSQL world, I have done a vast improvement. It's really designed for these primary key reads instead of that scatter gather across the cluster. This means that the time I'm loading is almost negligible. Compared to that 120 milliseconds, I can now load a lot more data, or I can give more of that time slice back to the analysis engine to make sure that this isn't fraudulent or not. Some of that came from Aerospike's optimized for primary key reads. Some of it came from that merging of records back together. The other nice thing is Aerospike doesn't cache the records. These records are coming off drive. So we saw that degradation in performance that Postgres had. If I'm using Aerospike, however, I'm reading those records directly off the drive in this test. And therefore, there is no warm-up. There's none of that variability of latency we saw with Postgres, where if it was on drive, I got terrible performance. If it's in memory, then I got good performance. This is as every one of those records is being read off drive. So it's a very efficient way of loading the data. Now, grouping the records together like that can also apply to relational databases. I can put that into a JSON-B blob if I'm using a database that supports it and merge it that way. And it does get better results. It's not quite as staggering as the results we're seeing here, but they can be a bit better. But it's sort of counterintuitive to the way you typically relationally model things. So many people haven't heard of Aerospike. If you want to get started, if you want to look at Aerospike and get started with it, then it's really easy to do. There's a number of links here. We can just come onto the website and there's a sandbox where you can actually play with it. It's a very powerful tool and very worthwhile if you've got these sort of real-time needs of very fast data. Last thing I want to leave you with is if you do play with Aerospike and you're interested in finding out more, or you want to ask any questions, we have a Discord community. It's for developers like myself, talking to developers like yourselves, and would love to hear from you. Any questions would be greatly appreciated, or any thoughts or comments, I would love to hear from you. Thank you for listening. I hope this has been useful. There's a big difference in the way our world is moving with data. It used to be loading a single record was fine. Loading a small set of records was fine. But now we want to be able to load hundreds of thousands of records in real time, milliseconds. And that is difficult to do. And so that's why people are moving more and more some of the workloads of relational to NoSQL. NoSQL is not perfect. It can't do all those relational joins and everything you're used to in a relational world. But what I hope this has shown you is that there's different ways of modeling the data and that different problems call for different sort of databases and different use cases require different solutions. And there's tools out there that can solve them, but there is no perfect database. No database can solve every different use case that we have in the industries at the moment. Thank you. I appreciate your time.
Hello again. Thanks to Tim for providing us with this recorded talk. If you got questions to him, you find all his contact information necessary in the chat, so don't hesitate to reach out to him. And before we jump to the final speaker of the day, just a few minutes break. And right back to FinTech and the final speaker of the day. He's CTO at Algorand Foundation, is an experienced blockchain leader and an expert in cryptographic engineering, and he also held various leadership roles in software architecture and applied cryptography. Welcome, John.
Hey, thank you very much for having me. Great to be here.
Thanks for joining. Before we start with your talk, would you mind sharing with us a bit about what we're going to learn from you today?
Certainly. So, hello, we are devs. I'm John Woods, and I work at the Algorand Foundation. And I don't know what your previous speakers have done, but I decided today not to come with a whole bunch of slides, and instead to try to tell a story in 3 parts. The first part is a little bit about my career and what I've learned working in FinTech for the last kind of 20 years or so. And I'm going to go into specifically what I kind of learned across my work in both traditional financial systems, in central banking and in traditional banks, and also working now at the forefront, I guess, of the FinTech space in distributed systems tech. I'm going to talk a little bit as well about what these distributed systems are, because I think there's a kind of a misunderstanding. Of course, there's so much hype on social media about cryptocurrencies and stuff, but really, I think they're an important part of the FinTech landscape. And I'd like to go into a little bit of the technical details around them and try to disambiguate the components that comprise blockchains. And I'm going to do so agnostically, not speaking specifically about Algorand, which is where I work. And in part 3, I'm going to try to talk a little bit about applied cryptography. You know, applied crypto is, to me, one of the most interesting I guess, areas of development, really, that I've ever worked in. I find it fascinating. And what I'm going to do is try to talk about applied crypto generally, maybe give a little bit of insight into some of the primitives, some of the cryptographic primitives and mathematical principles that are used in modern applied cryptography, and try to disambiguate that again. So rather than speaking very technically on it, I will kind of try to speak abstractly about it first, and then dive into some of the mathematical details, but doing so without slides. So wish me luck. And then finally, I'll finish on a little bit about why applied cryptography can really help you in a career in FinTech, whether you're working in blockchain or anything, or distributed systems, or indeed in traditional finance, where security and privacy is critical. And then maybe at the very end, if we have time, I'd love to chat very briefly about Algorand and what the work we're currently doing, employing these techniques, and indeed then take some questions from the audience. And for what it's worth, I like interactivity. I think it's great if it's a conversation. I'm not sure if we can facilitate that, because of course we're live or whatever, but I'm happy to take questions at the end or indeed at any time.
Yes, I would say let's tackle the questions at the end.
Sure.
We will just collect them for you. And yeah, well, 3-act storytelling, very good approach. It worked for Star Wars, and it will certainly work for us today.
Hopefully.
Jokes aside, the stage is all yours.
Thank you very much. So, hi everyone. I'm John Woods. I'm the CTO at the Algorand Foundation, and of course, a CTO is the chief of tech, and my job is to, I guess, set strategy and vision for Algorand Foundation, both looking at things that are very low level, like our network infrastructure, but also things like the dev tools for the platform that I work on, Algorand. And so maybe if I can speak briefly about my background and my career. I graduated from university or college with a bachelor in computer engineering. And from there, I started to work in a company called Ericsson. And so in Ericsson, I went in and I immediately was responsible for a block of code that was over 1 million lines of code. And of course, it was written in C++ in real-time rational rows, so kind of real-time embedded systems. And it was a baptism of fire. I didn't really know what I was doing, but I was surrounded by senior engineers that helped me learn quite quickly. And it was wonderful. I left Ericsson, though, because they left my native country of Ireland and they moved to China, and it wasn't a move I wanted to do in my early 20s. It was too intimidating for me. And so actually, I ended up working in banking. So my next role, I worked for Citibank, which was, of course, a large American merchant bank and consumer bank in the US. And at this point, it was fantastic because it was just when FinTech was becoming cool, right, in the early 2000s. And so across my career then, I've worked in a whole bunch of different things. So I've worked in building trading systems. I worked in foreign exchange. I spent nearly a decade in London working in foreign exchange derivatives, so building mathematical models and building risk management systems to risk manage foreign exchange derivatives. Then I came back to Ireland from London, and I spent a lot of time working with the Irish Central Bank, where I was a software architect, and I was responsible for building out financial systems within the Irish Central Bank, and indeed within the Eurozone, because of course the Euro is managed by the European Central Bank, and there's kind of a global system there between all the banks across the Eurozone, known as Target 2. So I was working on enhancements to that. And then when I left the Irish Central Bank, I moved into the blockchain space, and I've worked for 3 blockchain companies since. But I guess if I could look back at the portion of my career that was really, in traditional finance and in traditional software engineering, I learned a ton of stuff. And most of it was applicable to the work that I ended up doing over the last kind of 6 or 7 years in the blockchain space. So I guess notably for FinTech, I think that, one would have to say that blockchains, and not everyone likes the concept of blockchains. Some people would see it sometimes as wasteful around the proof of work stuff and the consensus mechanisms that use a lot of energy. But I think if I look at the amount of energy and the amount of work that goes into maintaining the traditional fiat systems, or traditional finance systems, I think modern networks like Algorand, Cardano, Ethereum, etc., which have switched to more sustainable consensus mechanisms, are very much a part of an interesting fintech landscape in modern times. And so to maybe give some insight into the kind of work that I did in the blockchain space, I worked for a company called Consensus, which was started by a gentleman called Joseph Lubin, who was the co-founder of Ethereum alongside Vitalik and Charles Hoskinson. And so at Consensus, I was building enterprise-grade apps on Ethereum. And so what you'll usually find with blockchains, okay, is that they're only really useful if your user requirements fall into kind of 3 broad categories. I'm not a guy who sees much value in shoehorning blockchain into everything just for the sake of it. And so when I was working on these architectures at Consensus, when I was building enterprise apps for big companies, these could be companies like Shell, Deutsche, Citi, also, trading companies like Cargill, Bunge, Amagi. So real traditional finance companies. And when we were building these enterprise grade systems, we tried to only use blockchain, of course, if it made sense. And so the 3 kind of verticals that I feel like blockchain really helps applications sing with are disintermediation. So when you're trying to remove a middleman in a process, whether that's kind of like peer-to-peer sales of tickets or peer-to-peer transfers of assets where you don't want to have a broker or a middleman, that disintermediation use case is really handled well by blockchain. The second is where you would have a need for veracity or provenance. So where you want to have a chain of trust or a cryptographic proof of the provenance of some goods, whether they're luxury goods like expensive clothes, or indeed whether it's something like pharmacy or medications, where you need to be able to trust the flow from the producer to the consumer. And then finally, I think another big area that things like blockchain really add some secret sauce to an application is in the arena of decentralized identity and self-sovereignty. This idea where your user will own their assets themselves, and it's not something that you can repossess, or they will indeed have a self-sovereign identity that they can use that's not controlled by a central source. So that they're high-level topics, but I feel like if your app falls into one of these things, blockchain can add something. And I built some huge applications when I was working at Consensus that used Ethereum, but also, of course, used traditional software engineering architectures and backends on cloud providers like AWS and GCP, etc. And so the blockchain bit was usually a small bit, but if your application had a need for one of these kind of 3 verticals, blockchain usually added quite an innovative solution. After I worked with Consensus, I finally moved on to working on the protocols themselves. And so I was the chief architect on Cardano, working with Charles Hoskinson at IOHK. And so there I led software architecture and applied cryptography for Cardano, which was wonderful. And I learned a ton of stuff there. And so in that role, I was responsible for the architecture, the engineering, the applied cryptography, and ultimately the QA and shipping of a product that was going to be affecting millions of users. And indeed, the product that we were shipping out the door had to protect the funds of billions of dollars of customer funds. And so we had to be very, very careful with that engineering. And as you'll see when I talk about it a little bit later, the engineering and thought that has to go into building a system like Cardano is really unprecedented. And then finally, I moved from Cardano to Algorand, where I work now. Algorand is another layer 1 blockchain similar to Cardano or Ethereum. It's programmable, and we think it's pretty cool. And so right now, of course, I set strategy and vision around the tech for the foundation on Algorand. And so let's maybe touch on blockchains and why I think they're cool. I think they're cool because if you're a fintech developer or you're someone who's a developer who's interested in security engineering or financial products, blockchains are, I like to think of them more as distributed systems, because not all of these blockchains actually use a blockchain. Some of them use DAGs or directed acyclic graphs or other technologies to store the transaction data. But these decentralized networks are really the forefront of the fintech space. As an asset class, of course, if you look at blockchain being about $1 trillion in market capitalization, so if you look at that whole digital currency space, it's only worth about $1 trillion. And of course, that's a lot of money to a normal person. But in contrast with global financial markets, where derivatives are worth, 40, 50, 60 trillion, where precious metals such as gold, tin, lead, copper, these things are worth, tens of trillions in some cases. The digital asset space is really still very small. And so it's 1/10 that of, say, just gold, as an example. And so there's potentially a lot of interesting careers that are going to develop out of this space. The reason I think they're so interesting is because from an engineering perspective, these blockchains that I've worked on, they combine such a broad selection of skill sets. And so, of course, in traditional software engineering, you tend to need, business analysis for requirements gathering, solution architecture or architects to build out the kind of macroscopic design of the system, and then engineers to implement in QA to QA. But what you'll see with distributed systems is that you have all of those things, plus you need distributed systems experts. So you need people who are able to build systems that are incoherently distributed. You need applied cryptographers to, of course, ensure the correctness and the veracity of the system. You need applied mathematics. You need specialists in concurrent programming. And so it really is the intersection of so many different disciplines that I find it absolutely fascinating. And what's interesting as well is when you normally ship a product out the door in traditional fintech. So, when I was working in London, I built translation layers for foreign exchange derivatives. So maybe I was trying to represent an FX option, which would have 20, 30 fields using a, simple markdown language like FPML or something like that. And, it'd be a case of form that transaction, send it to a translation layer where it gets parsed and then forwarded on. And so if you made a mistake in this, and I remember there were mistakes made where unit test wasn't maybe as robust as it should have been, maybe you'd end up with a deal that had that sold instead of bought. But it was something that was rectifiable. Whereas with distributed systems, where I've been working for the last 3 years, when we ship something out the door, you got to be extremely careful, because what you ship out the door is instantly or within moments subsumed by the rest of the network. The network then upgrades to this latest version that you're on. And if there are critical flaws in this, you're potentially risking the funds of millions of people who, in some cases, by the way, rightly or wrongly, may have a large amount of their personal wealth in these digital assets. But even more so, even if you get the security right, what you'll find as well is that bugs can be absolutely killer in this context. Because as you might imagine, when you ship a new product, many times in traditional software, you can kind of forget about the older product. You can say, well, we're deprecating that API, we're deprecating that API front or that front end or that back end. We are kind of moving away. We're going to upgrade the relational database, and then everyone should be good. Whereas with blockchains and with distributed systems, you have to maintain backwards compatibility forever. And so we have smart contracts, or I like to think of them as applications, but we have apps on the Algorand platform that have been written in the very first version of our language, which wasn't even Turing complete. And we have to maintain backwards compatibility, so that if someone tries to use funds that are locked in one of these early applications, that those funds can be released correctly. And so this is really a very tough challenge from a fintech and engineering point of view. Shipping products out the door that have to be bulletproof from a security, scalability, and resilience point of view, but also have to maintain backwards compatibility with your most early architectural decisions. And so it really is very, very tough. Okay, so maybe one last thing I will say is that when I was working in blockchain, one of the interesting things I found was that you're working with people who are incredibly capable. And so generally speaking, it's very top-end engineers, and it's people who really know their stuff. And so building teams that are coherent, that can work closely together is really tough. It's quite a challenge, especially when, for example, engineering can spend months developing a feature. It can be something that has spent a very long time in research and development, has got formal specifications, maybe follows formal methods. So we have executable specs where we've taken the research from mathematicians and academic researchers, and we've brought that down to an implementation in code that can be used as a reference. Engineering will then spend time building that into production systems in a more pragmatic way, and then you go to your QA and benchmarking, and you find that there's a regression where, for example, data propagation takes a couple of seconds longer, something that maybe has serious implications for your consensus mechanism. And so one of the challenges I think is interesting in working in fintech is, as a leader, is trying to keep everyone on the same page, pulling together, because sometimes it can be very difficult when teams feel like they are adversarial at times. Okay, so maybe that's kind of a quick look at kind of what it felt like to me to be kind of growing a career in across kind of fintech and indeed in the blockchain space over the last kind of 10 years or so. And so maybe I could just move now to the anatomy of these blockchains. I think, and I'm going to be speaking abstractly here, where I'm not going to kind of go into to concrete instances. But if you look at these distributed systems, as I've talked about, what they really are, and I think the way I like to grok them, is that they are essentially distributed operating systems. And so when you run code on Ethereum, it is not that different to running code on your local computer in front of you. I'm on a MacBook right now, and I've got Chrome executing, and Chrome has a TCP session open, and it's delivering the ones and zeros, representing my image to you guys. And so that's all being executed locally, of course, and the machine code is being run, the compiled machine code is being run by my computer locally. And so blockchains and distributed platforms like Algorand are really the same thing. They are like a computer. They're software implementation of a computer, because of course Algorand doesn't have a hardware CPU. Instead, it has a virtual machine. And so you can think of the smart contracts that run on these distributed platforms very much like applications that run in your local computer, except for rather than just running locally and not having any real mathematical assurance of the correctness of the execution of the application, they are running in a distributed context where they're running on many different computers at the exact same time. And each of those computers in the swarm of nodes or on the network ensures the cryptographic veracity of the execution of the application. And so smart contracts are apps, and platforms like Algorand and Ethereum and Cardano are just really distributed operating systems. And so if you look at these various blockchains that are out there, what you'll invariably see is that there's kind of three core tent poles to their architecture: the network layer, the consensus layer, and the ledger layer. And so the network layer is, of course, concerned with data propagation. And how do we have a peer-to-peer system that meshes well together, that can avoid certain levels of attacks, Sybil attacks or Eclipse attacks? And so if you look at using Cardano as an example, the network layer is a incredibly rich piece of work. They've built their own multiplexers, they've built their own data serialization techniques, and they've built a super high performance network layer which handles all kinds of attacks, and indeed really manages peer-to-peer networking really elegantly. And so I think sometimes people forget that, like, they see the blockchains, they see the price of cryptocurrencies on the market, or they see people talking about it, and they maybe forget some of the the care and the meticulous engineering that's gone into the various components. So that's kind of network. Each one of the various blockchains that are out there will have its own implementation of how it does peer-to-peer networking or data propagation across the network graph. Then the consensus layer. And so this will be really the kind of the secret sauce for most blockchains. This is where, you know, the rubber meets the road in terms of the energy use. It's usually the consensus mechanism, as famously put forward with Bitcoin's proof of work. It's usually the consensus mechanism that is essentially the driver of the energy use of the cryptocurrency. And so there's been incredible innovation across the industry of blockchains or of crypto assets in terms of the consensus mechanisms. And so it's what started with proof of work and advanced to proof of stake and delegated proof of stake has eventually advanced to even more elegant techniques. And so now we can run a consensus mechanism for a global blockchain that is processing billions of transactions, that is shifting, you know, hundreds of millions of dollars worth of funds each day, and do so with the energy use of around 60 to 80 kilowatts of instantaneous energy use for the entire network. And so this is like, you know, a kettle is like 3 kilowatts. So like a Tesla charging is like 50, 60 kilowatts. So this is like a, you know, an electric vehicle just being charged, and it services the needs of a global user base. And then finally, the last kind of component or secret sauce of these blockchain networks tends to be the ledger layer. And this is, as I mentioned earlier, for Algorand, the Algorand virtual machine, or for Ethereum, the Ethereum virtual machine, or indeed for Cardano, the Plutus interpreter. This is basically the software CPU, the rules around what is a valid transaction, the programming model as to whether or not the blockchain uses unspent transaction outputs as an accounting model, or indeed account-based balances as an accounting model. And so when you're kind of looking at maybe which one of these blockchains you might want to work in, they're the three components that you should be assessing in terms of the quality of the engineering. Okay, so I think, you know, I just wanted to kind of, frame the types of technologies that are used in blockchain, and just say that I know, although a lot of people would write these things off as scams or whatever, and I see it a lot when I'm browsing Hacker News, there's a lot of anti-blockchain rhetoric. I would just say that I think that the idea of a self-sovereign asset class, you know, a digital asset that's internet native, that is self-sovereign to me, that I control, or that one controls themselves, and one which leverages the intersection of so many different engineering disciplines, especially in light of how much work goes into making sure these networks don't fall over and indeed stay robust and stay secure. It really is a very interesting space if you're interested in fintech engineering. Okay, so maybe I'll dive into some of the crypto stuff now, if that makes sense. Hopefully this is enjoyable and not too boring. So the reason I got into crypto in the first place, and when I say crypto, I mean cryptography, not cryptocurrency, is because when I was working in the Central Bank of Ireland, and I briefly worked with the European Central Bank on a kind of a proof of concept digital euro, it occurred to me that it was critical to understand security engineering properly in order to be a good engineer. And so, especially in the fintech space, of course, there are many areas of engineering that don't require knowledge of cryptography or security engineering, but in the fintech space, invariably, you need to understand what you're doing in terms of privacy, in terms of security. You'll come across it all the time, whether it's digital signatures, attestation of Docker containers, you know, certificates that are being shared. And you'd be surprised. There's some master engineers out there who are way better coders than I am, who really struggle to grasp some of this cryptography stuff. And so I wasn't in any way formally educated on cryptography. Most of my knowledge I got from reading books, from asking questions on forums on the internet, or by watching you know, YouTube or Coursera type stuff. And so very much self-taught in terms of cryptography. And one of the things that I found most difficult when I was learning this stuff was just the kind of, I call it like a language barrier, but it's not really it. I mean, like the stuff is written in English, but it's just so difficult to digest. There's so much like jargon, right? And so I spent a very long time making sure I fundamentally understood all of the various primitives that are out there, from hashing functions to encryption. And when I say encryption, I'm not just talking about, okay, well, we'll use AES because that's what macOS lets us use, or that's what Windows says is good. And we'll use 256 bits because that's more than 128 bits. But to try to truly understand, what are the different modes of operations of AES? What does it mean if I reuse an initialization vector or a nonce value? Why is RSA 2048-bit not as strong as AES 256-bit? And so these types of things I think are really critical to understand. And I'm going to try to go through, just briefly for about maybe 5 or 6 minutes, the basics of modern asymmetric cryptographic schemes. And then maybe give a glimpse into the work we're doing around post-quantum cryptography, which I think is quite interesting. So in general, cryptography tends to be, at a mathematical level, something that implements a trapdoor function. And so this is something that's easy to do one way, but hard to undo, right? It's easy to fall into the trap, but it's hard to get out of the trap. And so we see this all the time in cryptography. If you encrypt a piece of data, it's easy to encrypt it. It's got to be. It can't be computationally expensive to encrypt because that would be useless. But it is computationally expensive to decrypt without having special knowledge. In this case, the cryptographic key that was used to encrypt. And then if we move away from encryption, which is maybe something that's quite simple, and move to digital signatures, it's the same thing. It's the same concept. It's easy to create a digital signature. It's easy to verify a digital signature, but it's hard to forge a digital signature, again, without the key material. And so my first insight into cryptography, where I really, truly felt like I understood it, was understanding the trapdoor function that lay at the heart of the various asymmetric primitives that were popular when I was learning this stuff. And the two trapdoor functions I'm going to speak about very briefly today are the trapdoor function that's used by RSA and the trapdoor function that's used by elliptic curve cryptography, which is what we use in blockchains. We use elliptic curves in blockchains generally because A, it was cool at the time when Satoshi was kind of writing this paper, and B, because they're quite fast, as you'll see why when I talk about RSA. Both RSA and elliptic curves both fall into, or elliptic curve cryptography, both fall into a bucket known as asymmetric cryptography. And this, of course, is this idea where you have one key for encryption and another key for decryption, one key for signature and another key for verification. As opposed to symmetric cryptography, which is the one that you'll know maybe, or that crops up a little bit more often, which is where you have a single password or a single key that both encrypts and decrypts. Okay, so the key insight that I learned about RSA was that what makes RSA hard, okay, is that it's hard to factor large semi-primes. And so let's break this down. Folks will know that a prime number is a number which is only divisible by itself and 1. So, for example, 3 is a prime number. Its divisors are 3 and 1. 7 is a prime number. Its divisors are 7 and 1. It turns out mathematically, if you take two prime numbers like 7 and 3 and you multiply them together, the product is known as a semi-prime. It's a semi-prime because the factors of that, of multiplying two prime numbers together, are both the primes themselves and their factors, so 3 and 1, 7 and 1, and also the two prime numbers that were multiplied. And so these semi-primes are the heart of the trapdoor function with RSA. And so it turns out if we take large prime numbers, so these are prime numbers that have 1024 bits or 2048 bits, and we take two of them and we multiply them together. So when you multiply, by the way, two numbers that are 1024 bits, you get 2048. When you multiply two numbers that are 2048 each, you get a 4096 bit number. It's extremely hard to factor that semi-prime number. And that's all it is. That's all the hardness of RSA is. When you're making RSA keys for the first time, what you're really doing is finding two large prime numbers and multiplying them together. There's a bit more to it. They work out things like Carmichael's totient and Euler's number and many other things. But ultimately, the heart of RSA is these two prime numbers. And that's why it's quite slow, and that's why it's not used in blockchain, because the way you find prime numbers that are used for RSA is to try to guess them. So you just pick a large number that is odd, and you test whether it's prime with a function like Miller-Rabin primality testing. And so I was captivated by RSA. This idea that we could take two prime numbers, multiply them together, and now we could send encrypted information to each other. This was, to me, fascinating. Also, it's where I had my first insight. The reason why RSA, 2048-bit RSA is not as strong as AES 256 is that for AES 256, the symmetric cryptography algorithm, what you're really doing is you got to go through and test all the different keys and see if one decrypts your message. And so you got to check, 2 to the power of 128 keys. With RSA, the way you attack it is not by taking, a 2048-bit key and testing all kind of like 2 to the 1024 keys. You don't go out there and kind of try to guess each one in the key space. That would be insane and would be harder than breaking AES 256. But instead, you focus on this semi-prime. You know the semi-prime because it's a public piece of information when you're using RSA. And rather than testing keys, you try to factor this semi-prime. And we have a technology called the general number field sieve, which is used. It's the best known technique to try to factor semi-primes, and it's pretty effective. And that's why the bit strength or the security strength of RSA 2048 is actually only about 112 bits. So I'm coming up really on time. So I'm going to quickly go through elliptic curves and then maybe talk very briefly about PQ. So elliptic curve is very interesting. Same trapdoor function we're trying to do. Okay, so how do you make a trapdoor function with elliptic curves? Well, it turns out that basically using modular arithmetic or using the discrete log function, we can effectively build a system on a two-dimensional Cartesian plane. And so like X and Y that you'll know from high school. And so we have a plane we call effectively a field. And on that field, we have an equation that draws a curve. Really, it looks like a cloud of points because it's discrete. And we can build a system where if I tell you where I am on the curve, on that XY plane, and I tell you where I started from, you will find it very difficult to guess how many hops I was from the origin point. And so, again, we're just leveraging mathematical techniques in order to build these trapdoor functions. What's interesting in elliptic curves is, and it's true of Bitcoin, Cardano, Ethereum, Algorand, is that the private key within a cryptographic system using elliptic curves is actually just a large number. It's a random number between 0 and 2 to the 256 in most of these systems. And so you could take any number in that range and it's a valid private key. So 10 is a valid Bitcoin key. It wouldn't be very good, but it's a valid key. Usually, of course, these numbers, as I mentioned, are usually selected somewhere in the range of 2 to the 255 versus 2 to the 256. And so they're just huge decimal numbers. And interestingly, and people tend not to know this, the public key, your receive address on these on these systems like Algorand and Cardano and others, is actually a point on an elliptic curve. So it's an XY coordinate. And so I know they take the XY coordinate and they mulch it down, they hash it, and they mess around with it. But fundamentally, your receive address on these systems is just simply a point on a Cartesian plane. I wanted to go through a little bit more on elliptic curves and how digital signatures work, but I don't think I'm going to have time just looking at the where we're at. So maybe what I'll just finish on is by saying elliptic curve digital signature. One of the last things that took me the longest to really grok and understand about elliptic curves was, what does it mean when you're signing something with a key? If I have a piece of data that says, pay Simon $10, what does it mean to sign that data? And what you'll find when you look under the mathematics is that signing something with a private key on Algorand or Bitcoin, whether that's a movement of funds or indeed it's something to interact with a smart contract, like a transaction that interacts with a smart contract or calls a method on a smart contract, what you'll find is you're really taking the message, the instruction, and you're binding the private key to it in a way that can be verified over the geometry of the elliptic curve. Finally, I would just say we are living in a world where technology is advancing at a profound rate. And I think things like ChatGPT-4, the state latent diffusion models, transformer models, the stuff we're seeing in ML and AI is incredibly impressive, and all using the parallelism of GPUs. And so we're seeing similar advancements in terms of computational engineering. And so we're getting closer and closer to a quantum computer that can run, that can harness the powers of quantum effects things like quantum superposition. And of course, the quantum computers we have now tend not to have a large enough number of qubits to be effective. And indeed, even if they did have a larger number of qubits, you would need these qubits to be in error correcting qubits. Okay, so they have to be able to correct for variance. But eventually, we will, I believe, arrive at a place where certainly governments have access to general purpose quantum computers. Quantum computers, by the way, are not going to be great at playing Red Dead Redemption 2. They're not going to increase your frames per second in City Skyline, but they are very good at attacking the trapdoor functions that I talked about, both in terms of RSAs, factoring semi-primes, and in terms of elliptic curve, solving for the discrete log over finite fields. And so we at Algorand, and in some other cryptocurrencies, but specifically at Algorand, because we have some very wonderful people working on this stuff who in some cases invented it, we are working now on how we transition away from these traditional cryptographic systems like elliptic curves to quantum resistant asymmetric signature schemes. So that is a signature scheme, which is the ability to execute a digital signature where a quantum machine is not able to quickly forge that signature. And so what you will see is in most of these quantum schemes, because what is a quantum computer really doing? It's exploiting quantum parallelism in order to attack these things. And so what you'll normally see if you look under the hood mathematically on the cool latest post-quantum cryptographic primitives that we have that NIST have recently attested as being good, they usually use some kind of form of parallelism. So they might use elliptic curves, but they will use super singular elliptic curves that are basically like stacked elliptic curves, like a bunch of pancakes. So you're using, one of these Cartesian planes, the x and y, but instead you're doing it many different times on top of each other. Or it might use lattices, where a lattice you might know as a kind of a cube of points in space. They will use n-dimensional lattices. So they will use lattices that have many dimensions, that work in dimensions that we can't visualize. And so it's a very, very interesting space. And I think it's just one last point just that it attests the fact that, working in distributed systems like blockchain, I found just incredibly compelling. You're at the forefront of engineering, applied mathematics, applied cryptography. And I think it represents everything that's great about FinTech and the innovations around it. I hope you found that interesting. I found it harder than I expected to explain these concepts without slides. I hope that was interesting. And I'm happy to have any questions on anything. It doesn't have to be about cryptography. If anyone wants to ask any questions, please feel free to do so.
Hello again, John. Thank you for your talk. Yes, I think at least I understood most of the things, also without slides, so it should have worked out. Thanks so much for that. And yeah, we got some questions in, so if you're up for a short Q&A session,
please shoot away, no problems at all.
Then let's dive right into it. So, first question, I love it. Can you explain the blockchain for dummies with a non-dev background? I've never understood how it works.
Yeah, sure. So when people say blockchain, they're just talking about a data structure. Think of a struct. If you're familiar with standard engineering, a struct can hold data. Or think of a tuple. It holds a set of data. A blockchain is simply a collection of transactions or data that is cryptographically linked to what we call the next block, which is another set of transactions. And so if you look at a blockchain, you zoom out, really is just a bunch of transactions, and the hash of those transactions is cryptographically written into the next block, and then so on and so forth. And so when you take this train of data and all these blocks, if you were to pull out a single transaction and try to replace it, you wouldn't be able to do so because you didn't validate the entire structure. And so that's the core inside of blockchain. And there is no such thing as the blockchain or a blockchain. There is no one canonical or absolute version of it. If you take Bitcoin as just an example, people will say the Bitcoin blockchain, like as if there's a place where the blockchain exists and people go and they add and remove data to it. But of course, that's not the case. The blockchain for Bitcoin and every other cryptocurrency has an identical copy on every computer around the world that is in the network. A bit like BitTorrent, if you're familiar with that, you'll have seeders and leechers. You will have seeders in Bitcoin. You will have people who have the full blockchain, and they help distribute the blockchain around the network. And then just to say that, yeah, more advanced blockchains, if I can say that, like Algorand and Cardano, have added on top of that ability to move funds. They've added programmability, so you can put Turing complete applications on the chain that execute business logic. And like I mentioned earlier, blockchains are useful for certain use cases, not for everything. And I think they're overused at times. They are useful for disintermediation, for provenance or veracity of information, and for self-sovereignty.
Thanks for clarifying that, John.
Hopefully.
Hope it helped.
Hopefully.
One or the other. And let's jump to the next question. Can you give a personal outlook on the future of blockchain? Some use cases apart from crypto, maybe.
Yeah, sure, absolutely. So this is important. This is an important thing. I think most people got into blockchain, including myself, if I'm being honest, trying to speculate. And so, my first cryptocurrencies were things like Bitcoin and Monero and others, and I was buying them before I became maybe more entrenched in the industry and more understanding of the ideology. I was buying them because I wanted them, to increase the value of the money that I put in. But what I've learned over the last kind of decade or so working in these systems is that they have use cases that can really make a difference. And I'll tell you about like just two that are on Algorand, but they could be done on most blockchains. One is in Afghanistan, there's parts of Afghanistan where women don't have access to the financial system the way others do. And so there's suppressed parts of society, both families and women in parts of Afghanistan. And we have built a system where there's 10,000 stores in Afghanistan where you can go in and you can use this digital version of the local currency. The currency in Afghanistan is called the Afghani. And so we have a digital version of the Afghani that exists on Algorand. And so now these women have the ability to have financial independence. They don't need a bank. They don't need to go down to some building to set this up. They can set this up in their home, and people can send them money, and they can use that money locally to actually get access to real things. And so this is an example of where blockchain has been used to break down borders, to kind of give self-sovereign control of wealth to a person who by society wouldn't be allowed it. And so I think very powerful. Another use case that I think is super cool is this. It's a technology. It's on multiple chains. It's not just on Algorand, but it's called book.io. And so I'm an avid reader. I go to Amazon. I have my Kindle. I download lots of books on Kindle. I really enjoy it. And so the thing is, though, I have like this huge collection of books that I've bought, right? And Amazon effectively have a backend somewhere. And by the way, I love Amazon Web Services. It's a great product. But they have a backend somewhere that are serving me these books. And technically, it's not beyond the bounds of possibility that Amazon will go under and I'll lose access to all my books. And so what book.io has tried to do is take that, this again comes back to one of my use cases, which is self-sovereignty, take that license for owning the book and give it to the individual. And so rather than the books being stored in Amazon's backend, when you buy a book on book.io, the book is sharded, broken up into parts rather, encrypted, and those parts of the book are stored on decentralized networks. And so when a user, even in 10 or 15 years comes along and they for example, maybe Amazon's not around, they can still open up their book because they have self-sovereign control. They know a key that can fetch all the parts from distributed systems and bring the book back whole again. So, I think that there are lots of use cases of blockchain outside of crypto, which usually fall into self-sovereignty or disintermediation. My personal favorite will be when Ticketmaster gets crucified and destroyed, and I don't have to pay, $10 extra to see Guns N' Roses because they need some fee, and instead I can maybe buy a ticket from a person who's already bought the ticket but can't go that evening for the face value. And so these types of things are where blockchain, I think, is really going to make a difference.
What a bright future that might be.
Fingers crossed.
Thanks for sharing this as well, John. And we jump right to the next question.
Mm-hmm.
Also related to the future, what comes after blockchain? Quantum or something else?
So, blockchain is just the word, I think, has taken on a life of its own. I mean, ultimately, like I mentioned in one of the earlier questions, it's just a data structure. It's just a data structure where the data is chunked into parts that are cryptographically linked. there's nothing magic about that. You could store a blockchain in an SQL database if you wanted to as blobs. The magic really is not the blockchain itself, but rather how all of the nodes, how all of the computers that are in the network stay in sync together and agree on valid transactions. That's the magic. And so where I think the industry will go is further decentralization, this idea that there is even less and less control by foundations and by engineering, and truly that the networks are owned by the users. And of course, I do think that we're going to see the advent of quantum machines, which, by the way, as I mentioned very briefly earlier, a quantum computer is just simply a different way to process information, harnessing the power of quantum phenomena, such as quantum superposition, where you can, rather than having a 1 and a 0, which we have as a bit in a traditional system, you would have a qubit, which is both a 1 and a 0 at the same time. And of course, you'd want a degree in quantum mechanics to understand this stuff, but ultimately, the computer can kind of parallelize certain types of processing. And so when a quantum computer exists, there'll be bigger problems than just blockchain, because these quantum computers, as I mentioned earlier, are not great for every type of computation, but they're specifically good at certain types. And indeed, factoring is one, and solving discrete logs is another. And so these machines will break the cryptography we use on the broad internet. It will break communications. If you're using iMessage or WhatsApp and you're talking to your wife or your husband or your boyfriend or girlfriend, that information is encrypted right now using technology that can be broken by a quantum machine. I'm on this connection right now. I see the HTTPS logo on the top of my browser. That will be broken by these quantum machines. And so what's coming, I think, for blockchain and for quantum is the standardization of cryptographic techniques that are resistant to these quantum computers, and then the proliferation of those techniques, because what you'll find is cryptography is very hard to do in production systems. There's, a small mistake can end up destroying the security of the system. And so what we'll probably see is that it'll take a long time for projects to add quantum technologies. And by the way, Chrome, just as an example, because I'm on the Chrome browser, by the way, you shouldn't use Chrome because it's full of ads, but it works very well with most websites. Chrome added quantum cryptography to Chrome in version 1.16. They added, I think it was Kyber, which is a post-quantum key encapsulation scheme. So real companies are taking this seriously, and they're writing code in their browsers right now that affects the security of fintech products. And so if Google takes it seriously, you should too. And I know I've got the Google t-shirt on, but I haven't actually worked there.
Okay. What should we use instead of Chrome?
I think Firefox or Safari.
Firefox or Safari. All right.
Yeah.
Thanks also for this. And we jump to the next question. Okay, you kind of talked a bit about other use cases and everything, but what do you think are the most exciting developments or trends in the blockchain space as of right now?
Sure. So I think the idea of self-sovereign identity is probably the most exciting, one of the most exciting trends. And the second most exciting trend for me is privacy. So I'll touch very briefly on both of these. I would love the idea that if I open my cryptocurrency wallet, rather than see a balance in some token, instead the root of that experience, that user experience on my mobile phone or on whatever device, is my identity. So that these cryptographic keys, a bit like Keybase tried to do years ago, these cryptographic keys are really the core of, like, when I'm sending a message to my friends, they truly know it's me. And we're living in a world with all these deep fakes, man, and I, like it's incredible, the machine learning stuff. By the way, I think it's wonderful, and I think machine learning is incredible. It should be. I applaud the development, but people have to be more careful than ever about what's real and what's not, whether it's news or images or text or whatever. And so, this idea that you'll be able to attest or cryptographically sign something with a post-quantum primitive to prove that you indeed said a thing or you indeed took a photograph, that is, I think, very important. Secondly, privacy. Blockchains, by definition, most of them are not private. If you give me your account details for Bitcoin, I can see how much Bitcoin you have in that account. That's not good. We need to bring privacy to blockchain for it to be truly effective, because otherwise, maybe you're my friend today, and then tomorrow I find out you've got millions of dollars. Now all of a sudden we think differently of each other, and so that's something that has to be fixed.
Yeah, that's true. Thanks, John. And we got one more question as of now.
Sure.
What's the biggest pitfall about blockchain, and what's the worst thing that can happen?
Sure. So two things. One, blockchains in general are are bleeding edge technologies. I just talked about consensus, network, ledger, all the code that handles the rules for how transactions are processed, all the cryptography. Software has bugs. We know that there's bugs in our operating systems that we use. There's bugs in our iPhone. There's bugs in our Android phone. So there are unknown bugs in these cryptocurrencies that are out there, because there are tens of thousands of lines or hundreds of thousands of lines of code. And so the worst thing that can happen is that you have a catastrophic failure in terms of the correctness of consensus or the transaction processing. And if there is a catastrophic failure in one of these cryptocurrencies, of course, the value of that cryptocurrency will fall. And so I think probably one of the biggest pitfalls is robust engineering. And something we very much try to focus on in Algorand is the quality of the engineering and making sure things are QA'd to the highest standard. But like all software, the worst possible thing that can happen is that you have a catastrophic failure of the network. And like I mentioned earlier on, when you ship these cryptocurrencies, if you have a bad build of Chrome, it's okay. You ship another build, and no one is hurt. If you have a bad build of Cardano or Algorand, potentially people are going to lose a lot of money. And so that is probably one of the biggest pitfalls. The second one I'll just touch on is the self-sovereignty. I keep saying the word self-sovereign. What I mean there is that you own the key. You're responsible for your savings. You're responsible for your own account, not the bank. And so if I find that I've been defrauded, I can call my bank and say, guys, I didn't spend that. I can prove it, whatever. And they usually will give you the money, and they'll go to the police with the crime. That's not the case on blockchain. Even I, as someone who's a leader in Algorand, if I lose my keys for Algorand, I can't ask anyone in the Algorand Foundation to give me the money back. There's nothing there. And so that's a huge responsibility, because if people have their life savings or their retirement portfolio in this thing, and they lose the keys because they have a fire in their house or something like that, that is absolutely hugely detrimental. And I think it's a pitfall. People have to just be aware of the responsibility that comes with self-sovereignty.
And of course, that's a responsibility we are not used to anymore.
Sure.
We are used to, let's make a bank account. You get my data and you can make whatsoever with my money, but I can be sure that I get it back. In what way?
Absolutely.
In one way or another. That's
absolutely.
That's
By the way, there's
point,
also the aspect that your bank can freeze your funds, if they wish to. And so it's a double-edged sword.
Yeah,
but,
of course.
But you're right. It's a level of responsibility people have never really had before. Yeah.
They need to look out for my own money.
Yeah.
And in the meantime, we got one more question in from the audience. Mm-hmm. So, which applications are currently in high demand that are not yet available on the Algorand blockchain, for example?
Sure. So we on the Algorand blockchain, we have pretty much all of the same types of applications that you would see on Ethereum and Cardano and others. So we have apps across the general spectrum of DeFi, this decentralized finance stuff, swaps, derivatives, options, that kind of stuff. I think in general, we have pretty much an analog for everything that's on those other chains. Something that we're going to be rolling out soon is the ability to use your Algorand keys or your Algorand identity to sign into websites. And so it's actually, I think we're trying to push forward the use cases beyond these more traditional things that you would see on blockchains, the ability to swap currencies back and forth and trade, and try to think about this thing in a more novel way. And maybe one other thing that's coming to Algorand that I don't see on other blockchains is that this month we're rolling out a developer preview. So it's kind of a developer beta. It's not fully cooked yet, but it's pretty great, which allows you to write your smart contracts or your applications on Algorand in Python. And so you can just take normal Python, off-the-shelf Python syntax, and start writing smart contracts and expressing your business logic using pure Python. And so we think it's going to really open up Algorand to a whole bunch of developers. I'm sure in your audience, many folks out there will be familiar with Python. Not as many will be familiar with the low-level assembly languages of smart contracts. And so, yeah, it's something we're quite excited about.
Awesome. Then good luck with this. And yeah, John, since this was the last question.
Thank you.
All there's left to say for me is thank you so much for the talk. Thank you so much for the Q&A. Really, really interesting stuff we learned from you today. Thanks for all these insights. And hopefully we see each other again on another live day.
Thank you so much. Cheers.
Cheers. All right. And now that also the FinTech Day comes to an end, just some more information first and foremost. Thanks to SingleStore, our partner of the day. Without partners like these, we would not be able to make events like these. So really thank you. You can scroll down on the live page and click on their logo. We linked it there, and have a look on all their offerings. Also, if you're interested in our coding competition, Code 100, go to code100.dev. The first edition of the roadshow will take place in Zagreb on November the 29th as part of the Advanced Technology Days. So check this one also out. And also, yesterday, we published the upcoming season 7 actually, which starts in January the next year, 2024. You can check this out, and we hopefully see each other next week on November 15th, when it's all about machine learning. Until then, bye.